Yes, I'm serious. Today, we are going to solve 100 precalculus equations, and of course, we are going to do them in one take. That's the clock on the wall already, and of course, I got my equations here, and of course, this right here is in the description, so you guys can go check it out. So, we have different types of equations that you'll see in your precalculus class, including polynomial equations, logarithmic equations, exponential equations, and rational expressions, and of course, trig equations, and all that good stuff. So hopefully, this video can help you master your equations solving skills. And I'm doing this with you guys, all right? Make sure you try the questions first. Let's say 6 hours. Okay, first one. Square root of x plus square root of x plus 1 is equal to 5. Let's isolate this square root, so put that to the other side. So square root of x plus 1 equals 5 minus square root of x. And then square both sides. This and that cancel. X plus 1 equals expanded binomial. Take 5 squared, we get 25. This is a minus, so put on the minus. And we do 2 times this and that. 2 times 5 is 10. And then we also need a square root of x. Lastly, we add this term square, which is just going to be x. Now, as you can see, we can actually just minus x to both sides. This is out, and then I will subtract 25 on both sides. So this and that cancel. That will give us negative 24, and that's equal to negative 10 square root of x. Then we will just have to divide both sides by negative 10. And then I'm going to write this down first. We can get rid of the negative and divide this by 2. So on the top we get 12, on the bottom we get 5, and then we just have to square both sides again. Cancel, cancel. Ladies and gentlemen, x is equal to 144 over 25. And that is indeed the answer. You can plug in and double check it will work. So that's the first one, and we have a lot more to go. And by the way, I do want to mention before we continue, we are just going to be solving for complex solutions when we have polynomials. So if we end up with like exponential equations, we are not going to worry about the non-real solutions. Just keep that in mind. So the next one, here we have our first exponential equation. 8 to the 2x minus 3 is equal to 16. 8 and 16, we can write them as powers of 2. Have a look at the 8. That's the same as 2 to the third power. And then this is 2x minus 3. For the 16, it's the same as 2 to the fourth power. Now, we can just multiply the powers. 2 raised to the 3 times 2x minus 3. That's equal to 2 to the 4. So as you can see, this must be equal to that. When we have the same base, the powers must be equal. And then right here, we can just distribute, so that's 6x minus 9 equals 4. Add 9 to both sides, 6x equals 13. Divide both sides by 6, x is equal to 13 over 6, and then we are done. Okay, and here, okay. I'm kind of excited, and in the meantime kind of worried because I haven't done this for more than 2 years. But anyways, let's see. Okay, number 3. We have a cubic equation, x cubed minus 3x squared plus 4x, and then minus 4x plus 12 is equal to 0. So we have 4 terms, and one side is equal to 0 already. Let's try to factor it and do it by grouping because we have 4 terms. Let's try the first 2 and then the last 2. From here, we can factor out x squared, and then we get x minus 3 left. Now, when we do factor by grouping, be extremely careful. We will need to use a blue pen for the first time. If this is a minus, whatever this sign is, you just go ahead and write that down right away. If it's plus, just write that down too. Now look at the numbers, 4 and 12. We can factor out a 4. So what we are really doing is we are factoring -4, right? The negative from here. So now, if you look at this term, take -4x divided by -4, we get positive x. Then take 12 divided by -4, we get -3. So this is legitimately that this is equal to that, so we can factor this out again. And then we will have x squared minus 4, and that's equal to 0. Here we can factor out more. X minus 3, and yes, I'm going to have 100 factoring coming up pretty soon. Sometimes this year for sure, right? So difference of two squares, we get x minus 2 times x plus 2, and that's equal to 0. Now, of course, these are multiplying is equal to 0. We put this equal to 0 and then solve for x. So from here, add 3 to both sides, x is equal to 3. From here, we get x is equal to 2, and from here, we get x is equal to -2. There we have it. These are the three answers. And then next one, the first trig equation, number 4. Here, let's look at how to solve sine of x plus 1 is equal to 0. Now, to deal with trig functions equations, let's isolate the trig function. Here we have sine of x. So move the 1 to the other side. We're looking at sine of x is equal to -1. Now, if this number is like 0, -1, or 1, think about the unit circle. On the unit circle, remember sine is the y value. So the y value is equal to -1 only right here. This coordinate is 0, comma, -1. Now, we have to think about for what angle will give us this place. And the answer for that is 0 pi over 2, pi, 3 pi over 2. So the x, which is the input, is this right here. X is equal to 3 pi over 2. So if you just go around it one time, this is the only answer. But the truth is, we can go around this infinitely many times. We can start from here, keep adding 2 pi, or subtract 2 pi, we still end up with here. So 3 pi over 2 plus 2n pi, and just note that n is an integer. I'm not going to write it down throughout this video. This will do it. Okay. If you are my student, leave a comment down below and let me know. So that way I'll feel really touched that you are really actually watching my video to do the things that we are doing in class. All right, number 5. We have a quadratic equation, x squared plus 7x and then minus 3 is equal to 0. It's not factorable, trust me. 1 and 1, 1 and -3, or -1 and 3, not possible to end up with a 7. So let's go with the quadratic formula. The reason is because this number right here is odd. If you do it by completing a square, once you take half of that, you get fractions. So maybe just stick with the quadratic formula. And for the first time, let's go ahead and do a quick review. If we have ax squared plus bx plus c is equal to 0, then x is equal to -b plus or minus square root of b squared minus 4ac whole over 2a. The marker is new. It's slippery, but whatever. Anyways, that was my excuse. So now, a is 1. So here we go. X is just equal to b is a 7, so -7. And then plus or minus square root. B is the 7. Square that. Minus 4. A is 1. And then C is -3. And then all divided by 2 times A, which is 2 times 1. Okay. This is -7 plus or minus square root. Now for this, we just have to work out the inside. This is 7 squared, which is 49. And then minus times this minus will give us a plus. And then 4 times 1 is 4 plus times 3 is 12. So altogether, that's 61. Yes. So that goes inside of the square root, which is pretty nice because That way we don't have to worry about reducing the square root. Over 2 times 1, which is just over 2, and then we are done. Just like that. Now, number 6. We have a system of equations. So first, I tell you x is equal to 1/2 y minus 3. Second, I tell you 4x minus 5y equals -6. Have a look. 1, 2, 3, 4, 5, 6. All right, x is isolated, so it's a great idea to just use the substitution method. I'm going to put this into this x here. So 4 times 1/2 y minus 3. Continue. And then distribute. 4 times 1/2 is 2. And then y. And then 4 times -3 is minus 12. And then minus 5y equals -6. So combine. That will give us -3y. And then minus 12 is equal to -6. So add 12 to both sides. -3y is equal to -6 plus 12 is positive 6. Divide both sides by -3, y is equal to -2. But remember, once we got the y, we also have to find the x. X is equal to 1/2. The y is -2. And then minus 3. So half of -2 is -1 minus 3. So x is equal to -4. So here is the x, and of course I will also give you the y for free, because technically I titled this as 100 solve for x problems originally, but yeah, so we'll just solve for x. Anyways, precalculus equations. Okay, now we're going to get a rational equation. Number 7, we have x over x plus 3 plus 5 over 2x plus 6 equals 3 over 4. So how do we deal with this? Keep in mind, when we have an equation with fractions, we can multiply everything by the lowest common denominator to get rid of the fractions. And before we do anything though, we should check the denominators to see if we can factor it or not. This is x plus 3. Cannot do anything. 2x plus 3, 2x plus 6, we can factor out a 2. So I'm going to do this. X over x plus 3 plus 5 over 2 times x plus 3. And then this is equal to 3 over 4. And 4 is really the same as what? 2 times 2. So if you want to write it down like this, that's totally okay. Now, the least common denominator. We're going to multiply this equation. Have a look. I need to get rid of 2 and 2 right here. So I need to have 4. I need to multiply by 4. So that if I distribute it, they cancel. And of course, 2 and 4 will just end up with 2. So that will give us a whole number. And we also want to get rid of the x plus 3. So we need x plus 3 here. So now, take these two things, multiply with the first term. X plus 3 cancel, we have 4 times x. And then continue, plus, if we take this times that, I'm actually going to keep the 4 in red so you guys can see this right here better. But for the next part, x plus 3 will cancel. 2 and 4 reduce out to be 2. So we will have the 5 here times 2. Again, reduce out. 4 divided by 2 is this 2 right here. That's why it's 2. And then that's equal to, now if we take this times that, this and that cancel. So we have this 3 times the x plus 3, like this. Now let's just go ahead and clean this up. 4x plus 10 equals, distribute it, we get 3x plus 9. Combine terms, minus 3x to both sides. And then in the meantime, minus 10 to both sides. So that that's just x. And that's equal to -1, right? 10 minus 9. So 9 minus 10 is -1. And you should always check to see when you plug in this number into the original denominators, if you put -1 here, do we get 0? No. -1 plus 3 is 2. Likewise, if you put it here, you also don't get 0. So that means this is going to be good. In fact, you should also be aware that when you have this equation, you should write down that x cannot be -3, because otherwise that would make the denominator 0. But we didn't get -3, so that's pretty good. Okay, number 8, I can fit in here. We have our first logarithmic equation. Log base of 36 of 3x plus 15 is equal to 1/2. So how do we solve this though? Well, keep in mind, if we have a log, we are going to pretend that these two are our exponents, and then we are going to do 36 to this exponent and then 36 to this exponent. Because when the base of the exponent and the base of logarithms match, they cancel out. Or you can also look at it like this. When we have log base 36, the inside is going to be 36 raised to the 1/2 power. Yeah, it's equal to that. Either way though, you see this right here is 3x plus 15, and that's equal to 36 to the 1/2 power. Let's do a quick review. Now this is 36 to 1/2 power right here. 1/2 power, it's the same as taking the square root. So we just get 6. So we just have to now solve this equation. Minus 15 to both sides. 3x equals 6 minus 15 is minus 9. And then divide both sides by 3. X is equal to -3. So as you can see, when you're learning how to solve equations, I think the most important part is pay attention what the first step is. Like for the rational equation, you will have to multiply everybody by the lowest common denominator to make it easier. Once you did the first step, the rest, it will go back to like the regular equations. Likewise here, when you have a log equation, once you did the first step, seriously, the rest is just like a linear or maybe sometimes a quadratic equation that you should be able to solve. Now, for logarithmic equations, you should always check when you're plugging this into the input here, do you make the inside equal to a negative number? Because remember, when we have log of any base, if the inside is a negative number, this right here is no real. It's not real. So we are not going to consider that. But if you put -3 in here, 3 times -3 is -9 plus 15 is a +6, which is totally legit. So this right here is our answer. Number 9, absolute value equation. Absolute value 3x plus 1 minus 2 is equal to 4. So to solve this absolute value equation, first isolate that absolute value part. Add 2 to both sides. So we have this is equal to 6. Now, we're going to take out the absolute value. You can do this to show work if you would like. You can literally just kind of take it out. However, be sure you have the plus or minus on the right hand side, because if the inside turns out to be +6, that will make this work. Or if the inside turns out to be -6, if the inside turns out to be a -6, absolute value of -6 is also equal to 6. So two situations. So right here, I'm going to first consider 3x plus 1 equals 6, and the other one, 3x plus 1 equals -6. Again, you see, once you know the first step, or maybe first two steps, the rest is really just like equations that you have seen before. So right here, -1 to both sides, divide 3 to both sides, x is equal to 5/3. Right here, -1 to both sides, -6 minus 1 is -7, and then divide the 3 here, -7/3. And for absolute value equations in this situation, I'll tell you both of them will be legit. Okay, number 10. We have another trig equation. So this time is 2 cosine x equals negative square root of 3. So we are going to isolate the cosine x part. Divide the 2 to both sides. So cosine x is equal to negative square root of 3 over 2. Now, how do you solve this though? You have two choices. One is you kind of just remember the unit circle. Not my favorite in my opinion. The other one is that you use the reference triangle method, which is what I'm going to show you. Don't worry about the x, because sometimes data, this right here represents the angle. But on the xy plane, cosine of an angle is equal to the following, okay? Cosine is the x value over the y value. This x and that x are different because right here I'm going to draw a picture. Take x to be negative 3. I'm just going to write that this. Sorry, it should be x over r. Take x to be negative square root of 3 and r to be positive 2. In fact, r is always going to be positive. Okay, x can be negative or positive. So take x to be the negative square root of 3. So I will have to go here. Let's say here is negative square root of 3. And then r is 2. So that means the distance from the origin to here, this right here is 2. And as you can see, we are going to get a special right triangle. This right here is square root of 3. If you just look at the length, this right here is 1 and that right here is 2. So this little angle is just going to be 30 degrees, which is pi over 6. However, when we are trying to solve for cosine of one angle, to measure the angle, we have to start with the positive x-axis here, and we go all the way to here. Now, the whole thing to here would be pi, but we don't have that much, so we have to minus pi over 6. Pi minus pi over 6, get the common denominator, which is 6, 6 over 6. 6 minus 1 is 5, and then with the pi over 6. So the first answer, the x, the input here, from this picture is 5 pi over 6. Now, for the second one, just to make it more clear, I'm going to do this in blue. Again, when x is equal to negative square root of 3, we actually have another possibility. I can still go right here. That is still negative square root of 3. For the r though, it's positive. I can actually draw like this, because the distance from the origin to that point, 2, r is always positive. And then here, you can look at this as negative 1. But if you look at the length, this is still a 30, 60, 90 special right triangle, with this angle still being pi over 6. But same deal, we have to count, we have to measure the angle from here all the way to the terminal side. This time though, from here to here is pi, but we have to go additional pi over 6. So get a common denominator, add up the fractions, that'll be 7 pi over 6. So the first answer is that we started at 5 pi over 6 right here. And we actually have another answer which starts at 7 pi over 6. Now, how many ways can we get to this terminal side? Infinitely many. Starting from here, just go ahead and add 2n pi, where n is an integer. And then right here, same thing. Once we have this answer, just add 2n pi. So we have two sets of solutions, and we actually have infinitely many solutions. Okay, that's the first 10 questions. So 10% done. Now we have 90 something to go. Well, if you have seen my videos before, if you have seen my videos like this before, you know we don't just do 100. So that's why I said 90 something. Number 11. This is like a compound inequality. 3 less than or equal to 1 minus 4x over 2. Yeah, I just realized I should have written 100 precalculus equation slash inequality, but anyway, anything that you have to solve, I solve for x. So notice that x is in the middle. We have like this two inequality, and this is like sandwich in the middle. We can still do the following. Get rid of the fraction, multiply everybody by 2. So that this and that will be out. So this is 6. And because we just multiply everybody by positive 2, we do not have to flip the inequality. 6 is less than or equal to 1 minus 4x less than 10. Then I'm going to subtract 1 to all 3 sides. So here I'm going to write down my steps. And we're subtracting, we don't flip the inequality either. So this is 5 less than or equal to negative 4x, and that is going to be 9. Now, to get the x by itself, we divide everybody by negative 4. Do it here, and also do it here. So we get the x by itself, but now, because we are dividing by a negative number throughout, so we do have to flip the inequality. This right here is negative 5 over 4, but we will have to say greater than or equal to x. And then here, also flip the inequality. This is negative 9 over 4. You can put negative in the front, or on the top, or on the bottom. Doesn't matter. But this is not usually how I like to look at the inequalities, because we usually like to have the smallest number on the left, right? So we're going to kind of flip this a little bit. I will write this down first. Negative 9 over 4, and then less than x, and then less than or equal to negative 5 over 4. Because the truth is, this is indeed less than that, okay? And then for the inequalities, I am going to just answer this with interval notation. So x is in between of these two numbers. I'm going to just say we start at negative 9 over 4, go up to negative 5 over 4, not including that number, but since this is less than or equal to, so we are including this number. So I'm just going to write it like this. Or sometimes if you want to leave like this, that's fine too. But yeah, practice interval notation here. Okay, number 12. Another system of equations. 3x plus 2y is equal to 11, and then 4x minus 5y equals 30. I don't have x or y isolated. So here, I will say it's most likely easier if you try to do this by elimination. And to do so, you pick a variable first, either the x or y, up to you. I'm going to choose y because this is positive, this is negative, so the signs are opposite already. Now, I'm going to look for the lowest common not a denominator, but the multiple of 2 and 5, which is just 10. So what I'm trying to do is, I'm trying to make these two numbers 10 and 10. However, one of them should be positive 10, the other one should be negative 10. So that later on when we add them, they cancel out. If you choose to do x here, then you can do 12. But I will leave that to you. So right here, let's have a look. We have 2 already. How can we get to 10? Well, we need to multiply by 5, positive 5. Because here we have negative already. To get to 10, I need to multiply by 2. Just multiply by 2. That way, we get negative 10. So, take 5, distribute it. We get 5 times that is 15x. 5 times that is plus 10y. And then it's equal to 55. And then continue. 8x minus 10y equals 60. Now, add them up. They cancel. This is 23x. This is equal to 115. Then divide both sides by 23. X is equal to 5. And then we also have to get y, yeah? So I'm going to put y back to the, well, I'm going to put x back to the first equation. So 3 times 5 plus 2y is equal to 11. That's 15. So minus 15 to both sides, we get negative 4. And divide 2 to both sides, y is equal to negative 2. So x is 5 and y is equal to negative 2. So just like that. Oh, by the way, when we solve system equations, sometimes we also write the answer like 5 comma negative 2. And you have to know that this is a point, meaning the first number is x, the second number is y. And sometimes when you have an interval notation, if you are not including the endpoints, then that looks like a coordinate notation, like a point as well. So it might be confusing sometimes. You just really have to know the context of the question. But this right here is it. I'm going to write that down. I'm going to keep it like that. Okay, number 13. Here we have an exponential equation with e 3e to the 2x plus 1 minus 4 is equal to 56. 1, 2, 3, 4, 5, 6. Anyways, notice the x is in the exponent here, so we have to isolate this part first. Add 4 to both sides. 3e 2x plus 1 equals 60. Then divide both sides by 3. So that's e to the 2x plus 1 equals 20. Now, how can we get rid of the e? The answer for that is we take log base e, because if the base of the log and the base of the exponential match, they cancel. But log base e is precisely natural log. So ln both sides. And make sure when you take the natural log or any kind of log, you put that right in the front, never in the back. Okay, just like on the calculator, if you have to use a calculator to get the answer for this, you have to enter ln first. This and that will cancel, and I'm going to leave it like this. So 2x plus 1 equals ln 20. Put the 1 to the other side. So ln 20 minus 1, and then divide 2 to both sides. So ln 20 minus 1 all over 2, just like that. And of course, if you want, you can also write this as negative 1. If you put the negative 1 first, plus ln 20. The advantage of doing this is that now this is clear that we only have 20 instead of the ln, so you do not have to put a parentheses. If you only have like one thing instead of the natural log, you don't need a parentheses. So that's okay too. Now, number 14. It's like a combination of exponential equation and a quadratic. We have 4x squared e to the negative x squared minus 2e to the negative x squared, and that is equal to 0. So how do we solve equations like this? Well, I will tell you. If one side is equal to 0, then try to factor it. That's perhaps the most powerful technique. Notice we have this and that. We can factor that out. We can also factor out 2. Okay, let's do that as well. So from here and here, factor out 2. So 2. And then this part, e to the negative x squared. What do we have left? 4 divided by 2 is 2, and then x squared stays. This is out already, done with the first part. Minus, this is out, but we still have a 1. And that's equal to 0. Now we have a product of two things is equal to 0. So we make the first thing 2e to the negative 2x equal to 0. And the second thing, 2x squared minus 1 equal to 0. But is this possible? No. If you divide 2 to both sides, e to the negative x squared is equal to 0. But no matter what you put for x, an exponential function can never be equal to 0, right? E to the nothing, right, can be 0. So this right here is not possible. So I'll only hope to get the answers from here. Let me put the 1 to the other side. So we have 2x squared is equal to positive 1. Divide 2 to both sides. X squared is equal to 1 over 2. Then we are going to take the square root to both sides. Don't forget the plus or minus. So x is equal to plus or minus square root of 1 is 1. Square root of 2 on the bottom, just like that. And how did I write my answer? Yeah, I will just leave it like this. If you want to rationalize the denominator, you can also say plus or minus multiply square root of 2 on the top and bottom. So square root of 2 over 2. But I'm going to do that here. So 14 questions. Okay, number 15 is a little bit tricky, so I'm going to just tell you guys what to be careful of. It's just x squared is greater than 9. Let me tell you what not to do. So, it looks like x squared is greater than 9. Why don't we just take the square root to both sides and put a plus or minus and then get rid of this and say x is greater than or equal to plus or minus 3. Well, firstly, if you really read this notation, it doesn't really make that much sense. Because right here we are saying x is greater than positive 3, and then also equal to, wait, there's no equal sign, I'm sorry. Just greater. Alright, we are saying x is greater than positive 3, and another one is x is greater than negative 3. No, don't do that. The reason is because here we are dealing with a non-linear inequality. This is x squared. So be really careful. So how exactly can we do it though? I'm going to show you guys the safe way to do this for this one. First, make one side equal to 0. So move this to here. Still greater than 0. Now factor the left hand side. This is the difference of two squares situation. So we get x plus 3, x minus 3 is greater than 0. From here, I'm going to find out the numbers that we care. Meaning, how can we make this equal to 0? Well, x plus 3 equal to 0, subtract 3 to both sides, x is equal to negative 3. So we care about negative 3. From here, we care about positive 3. Now, I'm going to do a number line test. So draw a number line, make a mark. Negative 3 is smaller, so put it here, and then make a mark here. 3 is bigger, so put it here. Go back to the original denominator. Go back to the original inequality. It's just a greater than, right? So that means we are not including this. We are also not including that. Now, we are going to take a point, take a number that's less than negative 3, which is on this interval. So let's say if we use negative 4. Let's say here, we use negative 4. What we are going to do is, we are going to put negative 4 into here and here to see if we end up with a true statement or not. So have a look. Negative 4 plus 3 times negative 4 minus 3. Do we get greater than 0? Let me tell you. The truth is, you don't even have to compute it precisely. Just work it out if it's positive or negative. Have a look. This is negative. This is also negative. Negative times negative is of course positive. If it's positive, it's greater than 0. If it's true, then we are going to take that region, right? Take that interval. Now let's do another one. Right here, pick a number from negative 3 to 3. Let's pick 0. Don't pick that negative 2.5. Pick an easy one, right? Pick 0. Put it here, put it here. And you can even do this in your head, because if you put 0 in here, again, you just have to work out if it's positive result or negative result from these parentheses. This is going to give us positive results. And then when you put 0 in here, that will give us negative result. positive times negative, it's negative. We don't want that. Now, pick a number bigger than 3. Let's say 4. Put it here, positive. Put it here, positive. Of course, it's positive, so we are going to take this region. So, this is the safe way to do it. Now, I recommend you guys to do it like this. And finally, we just have to write the answer. And I told you I'm going to write the interval notation. But let me just tell you that this part is actually x less than negative 3. And this part is saying that or x can be greater than 3. So as you can see, earlier, if you just take the square roots to both sides, you will still end up with x is greater than negative 3. This right here doesn't make too much sense because x is greater than 3 and x is also greater than negative 3. But here, you can see that either we have x is less than negative 3 or x is greater than positive 3. This, we go from negative infinity up to negative 3, not including it. Union, meaning the other piece, we started at 3, not including that all, going to infinity. So that's the interval notation way to answer the inequality. Now we'll do it. Now, number 16. Okay, let me see if I can fit in here. Sine of 2x equals sine of x. Here, if the angles in the trig functions of the equation are not the same, make them the same. Double angle identity. So open it, we get 2 sine x times cosine x is equal to sine x. Next, you also have to be careful though. Even though we have sine x on the left and also on the right, but we cannot just reduce them out because otherwise you'll be missing solutions. What we have to do is put this to the other side. So we have 2 sine x, cosine x, and then minus sine x. That's equal to 0. And then we are going to factor out the sine x. So I'll put that down right here. And then we get 2 cosine x and then minus 1, and that's equal to 0. So from here, we can see that sine x is equal to 0. We have to solve that. And then from here, let's do this in our head. This has to be 0. That means cosine x. I want to the other side and divide 2 to both sides. Cosine x needs to be 1/2. So for this, remember it's a special number, 0, 1, or negative 1. Then we look at the unit circle. And sine is the what value? It's the y value on the unit circle. And the y value is equal to 0. It's right here. Because here we have 1 comma the 0 here. And then also here, this is negative 1 comma 0. So we have to have these two positions. Usually we will say starting right here and just add 2n pi, and then starting from here and add 2n pi. But the truth is, if we start right here and just add pi to it, don't we get to this point? Yes. And then if we start right here and then continue add pi to it, we get to that point, right? Yes. And in fact, we can also go backwards. Starting from here, go backwards, you also end up with that point, and so on, so on, so on. So from here, x is just equal to starting at 0. We don't have to write that down. We just need to write n pi. Technically, it's just 0 plus n pi. So this is one of the special cases that you are not really adding 2n pi by naming time. You kind of are as well because they happen to be lined up with just pi. Okay, so 0, pi, 2 pi, 3 pi, 4 pi, so on, so on, so on. And also the negative version of them. This right here will work. Now, cosine something equals 1/2. Cosine is x over r. So remember the definition. So x is positive 1, r is equal to 2. Just take these values. So I need a positive 1 for x. So let's say here is 1, and then r is 2. So it will look like this. Still, a 30, 60, 90 special right triangle. This is 1, right? X is 1, and then this is square root of 3. So this right here is pi over 3. And that's it. Starting right here, you turn that much, pi over 3. So x right here starts at pi over 3. But guess what? We could also draw the picture like this. Here is 1. Okay, this is 1, so this is the length 1. And I can also go down like this for r equals 2. And this right here, the y value is negative square root of 3, but length is square root of 3. This right here will still be pi over 3, right? But if we go from here and rotate all the way to here, how do we do it? The whole thing is 2 pi, and then we have to take away pi over 3. Now, get a common denominator. I'm going to multiply the bottom by 3 and then the top by 3. So this is 6 pi, yeah? 6 pi minus that, we get 5 pi over 3. So that part is 5 pi over 3. So another piece is 5 pi over 3. Now you can see this and that, they don't line up like pi and like this, right? They don't line up like a straight line. So we start right here, and then we just add 2n pi, the usual business. And then we start right here and add 2n pi, like the usual business. So we have all this for the solutions. Just like that. I forgot, I don't have the magic. Alright, so 16 questions. Okay, number 17. Here we have x to the 4th minus 5x squared plus 4 is equal to 0. So for this one, we have a trinomial, but it's a 4th degree. But this is actually just like a quadratic, because x squared, and then this is, the 4 is 2 times x, 2 times 2, right? We can do the following. Still factor it, and we can use the tic-tac-toe. Check this out. Ask yourself, what times what will give us x to the 4th power? We can try x squared and x squared. Look at the positive 4. What times what will give us positive 4? Let's try minus 1 and minus 4. Does this work? It does. This times this is negative 4x squared. This times that is negative x squared. Together, we do end up with negative 5x squared, and that's exactly what we needed. So this becomes this minus that times this minus that. Guess what? This is still a difference of 2 squares, likewise that. Factor this, x minus 1, x plus 1. Factor that, x minus 2, x plus 2. Or you could also just put this equal to 0 and then move the 1 to the other side, take the square roots. That's fine too. But you want to show it gets the factoring. Okay, from here, x is equal to 1. From here, x is equal to negative 1. From here, x is 2. From here, x is equal to negative 2. So we have 4 answers. Okay, number 18. Okay, ln of 5x minus 4 is equal to 3. How do we solve a natural log equation? You have to know that natural log is log base e, and when you have log, you are going to use exponents, right? Pretend they are exponents. Do this. We take e raised to that power. Likewise, you do the same thing to both sides. This way, this and that cancel. We just get 5x minus 4 equals e to the 3rd power. I'm going to leave it like this, e to the 3rd power. I'm not going to use a calculator. Then move this to the other side. Divide the 5 to both sides. So e to the 3rd power plus 4 over 5. And you can take this, plug in real quick. The inside is still positive, so this right here is still legitimate. So that's it. Okay, next one, number 19. Absolute value inequality. And I think I don't really see this kind of questions anymore. People don't really do this, but this is how you do it. When we have an absolute value of a quantity is less than or equal to a positive number, keep this in mind. I'll give you guys a quick idea, right? Absolute value. Let's say we have absolute value of x minus a is less than or equal to a positive number. What it means is that this right here is like the center, let's say a, and then I'm going to use actual numbers to make it like more clear. Let's say we have x minus 2, and then that's less than or equal to, let's say, 5. So what this means is that absolute value is the distance. The distance between x and 2, right? The distance between x and 2 is less than or equal to 5. So if you look at 2, what this means is that you can go out 5 units right here. So this part, it will be 2 plus 5. And then you can also go to the left 5 units. This right here will be 2 minus 5. And anything between, including the endpoints, are the solutions, because we want the distance between the x value and 2 to be less than 5. If you have somewhere here, the distance between here and here must be less than 5. So what I'm going to tell you is that when we have an absolute value inequality, if it's a less than situation, you can take out the absolute value. You are going to put x minus 2 in the middle, and then you are going to sandwich them in between of the negative version of that, which is negative 5, and then this right here is positive 5. And then from here, you can solve it by adding 2 to all 3 sides. So that's how we get this, and that's how we get that. So here, when we have a coefficient, remember this. I'm going to take out the absolute value. I will still have 2x minus 7. And I'm going to just write down the inequalities. The 11 stays right here, but right here, I'm going to have negative 11. So the middle is sandwiched in between of this and that. Because when the distance is less than a certain number, you want to be in between. So it's an and situation, you're in between. Now, this is another compounding inequality. So just go ahead and do the usual business to all 3 sides. Negative 11 plus 7 is negative 4. And that's equal to 18. And then divide everybody by positive 2. So x is in between of negative 2 and positive 9. And I'm going to write this as an interval notation. We go from negative 2 to 9, including negative 2 and also including positive 9. So that's how I'll present the answer. Now, number 20. I might need more space for this, but let's try. Square root of 5x minus 4 equals 1 plus square root of 3x plus 1. Okay. An equation with 2 square roots. Make sure one of the square roots is isolated and then square both sides. So here we go. This and that cancel, just inside 5x minus 4. Now, use the formula. A plus b squared is a squared. So 1 squared is 1. Plus 2 times this and that. 2 times 1 is just 2 times that. So 2 square root of 3x plus 1. Then we add this term square, which is just going to be the inside. Okay. Now, clean up a little bit. I'll just show you minus 3x to both sides. And then minus 1 to both sides here. And then also minus 1. Okay, so I'm looking at this being 2x. And then minus 5 minus 6. And that's equal to 2 square root of 3x plus 1. Continue. I can actually divide both sides by 2. Divide everybody by 2. Because I will still end up with whole number, so this is okay. this is x minus 3 equals square root of 3x plus 1. Now square both sides again. Cancel. Open that. X squared minus 2 times this and that, which is the 6x that we need, plus this square, and that's equal to this. Okay, then subtract 3x to both sides, we get x squared minus 9x. Subtract 1 to both sides, that will be plus 8 equal to 0. Factor it, x minus 1, x minus 8 is equal to 0. And now it looks like x is equal to 1 and x is equal to 8. But be super careful, because maybe one of them is fake, maybe both of them are fake, or maybe both of them are legit, I don't know. So when we have square root equations, whenever we square both sides, we must check the answers. Maybe we get fake answers. Let's try 1. If you plug in here, I'm just going to check here. Let's say check x is equal to 1. Plugging 1 in here, this is square root of 5 times 1 minus 4. And that is this going to be, I don't have any space, 1 plus square root of 3 times 1. It kind of fits. Oh, it does. Sorry. Anyways, this right here is square root of 5 minus 4, which is 1. And that's 1 plus 3 times 1 plus 1. Okay, so this is 3 plus 1 times 1. Just try to 3 times 1 plus 1. So that's 4. But that's 1 plus 2. So of course this is not correct. So 1, it's actually not true. So this right here is no, you have to get rid of that. That's an extraneous solution. Now check if x is equal to 8 will work. Plugging 8 into all that. So square root of 5 times 8 minus 4, is that going to be 1 plus square root of 3 times 8 plus 1? That's 40 minus 4 is 36. This is 24 plus 1 is 25. This is 6. That's 5 plus 1. Correct. So this right here is only x is equal to 8 only. Yeah. Okay. So 20 equations took like an hour. Maybe we can finish it in like 5 hours. I don't know. We'll see. Next, number 21. Here we have 2 sine squared x plus sine x. This is equal to 0. Notice we can factor the left hand side, especially the right hand side 0. So factor it. Factor out a sine x. That will give us 2 sine x and then plus 1. That's equal to 0. So we must have sine x equal to 0, or the other one is this portion equals 0. That means sine x, put the 1 to the other side, becomes negative 1, and divide the 2 right here, so we have negative 1/2. Now for this, once again, let's just do a quick review. Unit circle, y value here are 0. Starting at 0, add pi, 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 and then maybe backwards. So this right here gives us just n pi. Okay. Then for this right here, we have to consider both possibilities. Sine is the y value, right? Y over r. Take y to be negative 1, r is always positive. So draw the first picture. I can put negative 1 down here. That's negative 1. And then put this right here to be 2. And again, when you're doing this without a calculator, it's going to be a special right triangle. This is smaller, so this is pi over 6. Let me draw it bigger. So this is negative 1, and this is 2, and that's negative square root of 3. But that's pi over 6, which is 30 degrees. From here to here, though, it will be pi and then plus pi over 6, and then get a common denominator. So the first angle is 7 pi over 6. So I will say from here, x is equal to 7 pi over 6. But we can have another one as well, because we could also have drawn the picture like this. Check this out. Negative 1, and then this right here is 2. This right here will still be pi over 6. But when you go from here all the way to here, we will have to do 2 pi for the whole thing minus pi over 6. And then get a common denominator. So that's 12 pi minus pi, which is going to be 11 pi over 6. So this angle is 11 pi over 6. Remember that they don't line up to be on the line. So starting right here at 2 pi, starting right here at 2 pi. So these are the answers. Okay, that's it. Okay, number 22. Here we have x cubed minus 6x squared plus 11x minus 6 is equal to 0. So this right here has 4 terms, but if you try to do it by factor by grouping, you cannot really factor out what happened in the second 2 terms. You can factor x squared right here, so factor by grouping, it's not going to work. So what do we do in this case though? Well, we can use the rational zero theorem, or it's also called the rational root zero. Basically, we're just going to look at the factors of 6, which we have 1, 2, 3, and 6. Because 1 times 6 is 6, 2 times 3 is 6, so these are the factors of 6. And then put a plus or minus. Okay? Since the coefficient right here is just 1, these are all the numbers that we are going to check. These are all the possibilities to be the zero of this polynomial equation. Meaning that these are the only possible rational numbers. When you plug in, you end up with correct 0. I'm just going to try 1 first. So check. So I'll just say, if you take a look, 1, if you plug that in into all the x's, let's have a look. This is 1 minus 6, which is minus 5, and then plus 11, which is positive 6, and then minus 6. We do end up with 0. It does work. So that means 1 is an answer. So x equals 1 is a root. Then we can do the synthetic division. Have a look. Draw this little box. Write down the coefficients. 1, negative 6, positive 11, and negative 6. If x is equal to 1, it's a root, you put down this 1 right here. Now, this is how it works. Bring this down, which is 1, and take 1 times 1, which is 1. Put it here. Now, you add them up. Negative 6 plus 1 is negative 5. And continue the process. 1 times negative 5 is negative 5. Add them up, you get 6. This times this is 6. Put it here. Add them up, you get 0. If this number is a root, if you're doing all the computations right, this right here has to be 0. And this is the remainder. So what that means is that this polynomial can be factored as, because we have x is equal to 1, that means x minus 1 is a factor. And then the second factor is going to be from here. And this is going to be 1 degree less than the original. It was x to the third power, so right here we will have x squared and then x, no x. So we will have x squared minus 5x and then plus 6 is equal to 0. We can factor this more. X minus 1 this is x minus 2 times x minus 3 is equal to 0. Yes, I picked this. So the answer is just 1 from here, 2 from here, and then 3 from here. Could you have just like plugging all the numbers and guess them all correctly? Yes, 1, 2, 3, and then that will work. But sometimes it's not going to be this pretty though. We may end up with like imaginary solutions. And for polynomial equations, we will be solving for the imaginary solutions or complex solutions. All right, number 23, we're going to do just a linear one. Just like a one long equation. We have negative parentheses 12x plus 3, like this. And then minus 4 plus 5x equals 6x minus 7. And then minus 8x plus 9. In the parentheses, and you can totally tell that I created this equation because 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, where's 0? Well, you're about to see that. Yes, x is equal to 0, but have a look. Do the usual business. There's no tricks. It's just like the standard, right, the equations that you have done before many times. Distribute it and don't mess up, right? So negative 12x and then negative 3. And then minus 4 plus 5x equals 6x minus 7. And again, distribute this negative. So negative 8x minus 9. Whenever there's parentheses, you always distribute first. Then combine terms on each side. Here, this and that, we get negative 7x. This and this is minus 7. That's equal to this right here. And that is negative 2x. And this and that should give us negative 16. Why did I say that's equal to 0? Oh, I wrote it down wrong. Sorry, I wrote it down wrong. It happens. It's minus 12 plus 3x. I'm sorry. No wonder, because I know the answer is supposed to be 0, so I wrote it down wrong. I'm very sorry. So let me redo it. All right, so number 23, we have negative 12 plus 3x and then minus 4x. No, minus 4 plus 5x is equal to 6x minus 7 minus parentheses 8x plus 9. And you can totally tell that I created this equation because 1, 2, 3, 4, 5, 6, 7, 8, 9. And you might be wondering, where's the 0? Well, don't worry, you're about to see that. Here, it's just a regular equation. Remember, distribute whatever you have in front of the parentheses. Here we have the negative, so we have negative 12 and then negative 3x. Continue. They don't change right here. 6x minus 7, but this negative, distribute that into the parentheses. That's negative 8x minus 9. Now, combine like terms on each side. Right here, we can combine, let's do the x first. So this and that, that's negative, so that's positive 2x. And then this and that is negative 16. Okay, now here we have, then let's do double. So that's negative 2x. And then let's do like this. This and that is negative 16. Now move all the numbers to one side, all the x's to the other. I'm going to add 2x to both sides. I'm just going to make this super clear for you guys. And then I'm going to add 16 to both sides so that cancel. So that is 4x. And this is equal to 0. Now 4x is equal to 0. Do we have an answer for that? Yes. we have one answer, and the answer is equal to 0. You can divide both sides by 4 to show work. X is legitimately equal to 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, the 0 as the answer. Okay, the next one, I will have to erase the board for that. Okay, number 24. Here we have 6 sine square x plus cosine of 2x, and that's equal to 5. And then after that, we're done with the first page. Okay. The angle is 2x here. Let's fix that first. And this is sine square. The double angle for cosine, there are 3 versions. Because we just want everything in terms of just sine, well, that would be a great idea. So let's do the following. Keep this, but for this right here, let's write it as what? That's going to be 1 minus 2 sine square x. Right? This is the double angle identity. Now, let's see. This and that we can combine, which is quite nice. That's going to be 4 sine square x plus 1 is equal to 5. Subtract 1 to both sides. So 4 sine square x is equal to 4. And then divide both sides by 4. Yeah? So we have sine square x is equal to 1. Now, we can take the square roots to both sides, plus or minus. So we're saying sine x is equal to 1, and the other one is sine x is equal to negative 1. So we have to think about the unit circle real quick. On the unit circle, sine is the y value. To get 1, we are right here. Okay? And of course, you can say that's pi over 2 to begin with. So perhaps I will denote that real quick. And then usually, if you just have this answer, if you just have this equation, then you will say pi over 2 plus 2n pi, and you're done. But we also have this to consider. This right here, sine x is equal to negative 1, happens to be down here, and that is 3 pi over 2. Now, as you can see, this and that they line up with just a straight line. They line up. So the answer is just going to be x equals, I'm going to start at pi over 2 only, and add n pi to it. Because once again, instead of going from here and then 2 pi, 4 pi, just every time you go a whole loop, you can start right here, just add pi so you can get to here, which is going to include this answer, and then you can go here and then add pi to it, then you can get back to there, right? And you can also go the other way. And that's what the n is for. Integers, you have positive, negative, so they go either way. So this right here is just pi over 2 plus n pi. First page done. Okay, now 25. Absolute value equation. 3 absolute value. 5x minus 2 plus 6 is equal to 4. Okay, plus 16. 1, 2, 3, 4, 5, 6. Anyways, subtract 16 to both sides. So that will give us negative 12. Divide 3 to both sides. Absolute value of 5x minus 2 is equal to negative 4. This right here, no solutions. Go ahead and just write that down without doing anything further. Because the output of an absolute value cannot be negative numbers. Not possible. No solution right away. The output of absolute value cannot be a negative number. Done. Stop. The more you do, the more wrong it gets. So you have to know the concept. Right? You have to know the concept. All right, number 26. Log equation. Log base 2 of x plus log base 2 of x plus 1, that's equal to 5. This time though, we are having two logs. Let's combine them into just one log. If we are adding two logs together, we can just multiply the insides together. So this becomes log base 2 of, take this x, and then we multiply that by this part, which is parentheses x plus 1, because it has two parts, so put parentheses around it, and that's equal to 5. Now, we can get rid of the log by doing 2 to this power and also 2 to that power, so that this and that will cancel. This is what we have for the inside. We can distribute that real quick. That's x squared plus x, and then work out 2 to the 5th power, which is 32. Move this to the other side. X squared plus x minus 32 is equal to 0. If you try this, unfortunately, it's not going to be it's not factorable. So we're just going to use the quadratic formula because this is 1 and this is an odd number. So quadratic formula. X is equal to negative b, which is the 1 right here, plus or minus square root b, which is 1, square that, minus 4, a is 1, and c is negative 32. All over 2 times a, which is 1. Okay, this right here is negative 1 plus or minus square root. What's this though? This right here is, let me just indicate that right here real quick. That's 1, and then minus times minus is going to be a plus. 4 times 1 is 4, and then 4 times 3 is 12, and then 8, so it's 128, so that's 129 inside of the square root. Okay, and then all divided by 2. And you cannot simplify the square root, which I'll just box this right here for our answer. Okay, number 27, a cubic equation. 2x to the 3rd power minus x, it's equal to 14. One of my favorite cubic equation because 1, 2, 3, 4. Anyways, make one side equal to 0. We have 2x cubed minus x minus 14. It's equal to 0. Can we factor this with the tic-tac-toe method? Unfortunately not, because this is x cubed and this is x to the 1st power. The x won't pair up like nicely. So what can we do? Let's try the rational root theorem. So pretty much guess and check. That's the idea. So right here, I'm just going to try, let's say 1, but you can do this in your head. 2 times 1 minus 1 is not going to work. Let's try 2. 2 times that is 8, times that is 16. 2 works. So note that I'm just going to write it down like this. 2 times 2 cubed minus another 2 minus 14, it is going to be 0. So x minus 2 is, I'm just going to write it like this. X equals 2 is a root, or again, maybe a 0. So I'm going to use the synthetic division right here. 2. But do we have any x squared? No, we don't, right? So be sure we put a 0 right here. It's like a placeholder. You have to have that. So 2x cubed plus 0x squared, and then minus 1x, and then minus 14. X is 2, it's a root, so I will put a 2 right here, and then let's get started. Bring down this 2, take this 2 times this 2, which is 4, put it here. Add, we get 4. This times this is 8, put it here. Add, we get 7. This times this is 14, put it here. The last number has to be 0. So this means we can factor it. We get x minus 2 from here. And from here we can say 2 x squared, 1 degree less than the original. And then plus 4x plus 7, and that's equal to 0. Okay, so I did make this a little bit more difficult because this right here does not have any real 0. So for the first one, x minus 2 is equal to 0. Of course, x is equal to 2. I'm not even going to write it down like this. I'm just going to say x is equal to 2. But for this one, once you put this equal to 0, depends how I'm going to I don't have enough space. I'm going to do it by completing a square. 2x squared plus 4x. Either way, it's not going to be nice. So just quadratic formula on that, I guess. X is equal to negative. I can divide everybody by 2 and then complete the square, but 7 over 2 is a fraction, so that's why. Anyways, negative b, which is negative 4, plus or minus square root of b squared, which is 4 squared, minus 4 ac all over 2 times a, like this. So this will give us negative 4 plus or minus square root. Okay, now it's going to be 16, and then minus, that's 8 times 7, which is 16 minus 56, which is negative 40. Okay, and then over 4. But 40 is the same as 2 times 40 is the same as square root of 4 times square root of 10. So check this out. That's negative 4 plus or minus. Firstly, when we have a negative inside of the square root, we will get the I. And then, like I said, when we have square root of 40, this right here is the same as square root of 4 times square root of 10. And this becomes a regular 2, so I'll put it here. And we still have the square root of 10. And then over 4. But right here, I'm going to factor out a little 2 on the top. So that's 2 parentheses, negative 2 plus or minus I square root of 10. And then I'm going to reduce that by 2. So the first answer is x is equal to 2. The second answer is that x is equal to just this, negative 2 plus or minus I square root of 10 over 2. And remember, as we said, we will be solving for complex solutions for polynomial, just like this. So this is what we did. I should show you guys my, okay, here, this side is pretty white, and this side is like, oh, this is going to be very dirty later on. You'll see. Yeah, and then my hands is going to be really dirty later on too, so. Right, if you are still watching, yeah, leave a timestamp and let me know, and thank you so much. And you are doing great. If you are really watching this and then practicing this, then it's amazing. Next one, number 28. We have our first rational inequality. 1 over x minus 2 is greater than or equal to 3. So, for this right here, I will recommend you guys do not multiply the denominator to both sides. Okay, I'm going to do this. If you do 1 over x minus 2 greater than or equal to 3, if you multiply x minus 2 to both sides, this times that is 1, greater than or equal to this times this is 3, and then x minus 2, right? Distribute 3x minus 6. Add that to here, so 7 less than or equal to 3x, divided 3. So you're saying x is less than or equal to 7 over 3. But this is not correct. This is not correct. So here we are saying x is less than or equal to 7 over 3, but in fact we have another condition, right? So because here, if you just do this, you are saying x is any number less than or equal to 7 over 3. Well, 0 is less than 7 over 3, right? But does 0 work? But does this work? Well, if you plug in here 1 over 0 minus 2, is this greater than or equal to 3? Certainly not, because this right here is 1 over, it's negative 1/2. So no, right? So something must be wrong with this. Don't do it like this. The reason is because when you multiply both sides by x minus 2, well, you don't know if this quantity is negative or not. If this quantity happens to be negative, you will have to switch the inequality. So you will have to consider more cases. So I'm not going to do that. I will just show you guys the safe way to do it. Have a look. I'm going to put the 3 to the other side. So 1 over x minus 2 minus 3. Again, you just do this whenever we have a nonlinear inequality. Be super careful. When you have an equation, you can do the lowest common denominator to both sides like that, but for this you have to combine and then kind of investigate a little bit. I'm going to combine this and that together. To do so, I will need this right here to have x minus 2 for the denominator, and let's also do the same right here. So put them together, we have x minus 2 on the bottom. Here we have 1, and then minus 3 times x minus 2. That's greater than or equal to 0. Now I will distribute this right here real quick. So that's 1 minus 3x plus 6 over x minus 2 is greater than or equal to 0. So that's negative 3x plus 7 over x minus 2 is greater than or equal to 0. That's the most that we can do. Cannot factor in none of that. So now we are going to talk about the numbers that we care. First thing that we care is that if you look at this expression, x minus 2 is on the bottom, so you have to know that x cannot be 2 right away. Likewise, right here, x cannot be 2, so this is a number that we care. And the other number that we care is that the top, if you put negative 3x plus 7, just think about it making equal to 0, then you get negative 3x is equal to negative 7, x is equal to 7 over 3, and that's another number you care as well. So earlier, we didn't consider the 2. Right now we are. Be careful with it. These are the two numbers that we care. What do we do next though? Well, let's go ahead and have a little number line. I will just put it down right here. 2 is less than 7 over 3, so it will be right here, and then 7 over 3 right here. Now be careful though. We care about 2, but we are not going to include 2, because otherwise that makes the original denominator 0. So open circle. And for 7 over 3, if x is equal to 7 over 3, the top is 0. 0 is greater than or equal to 0. Because of the equal sign, we are including this number. Now we are just going to investigate what will happen on each interval. So plug a number and then do the test. Pick a number less than 2, let's say 0. If you put 0 in here, on the top is positive, on the bottom is negative, so altogether is negative. We don't want that. Now pick a number between 2 and 7 over 3. Oh no, that's a little bit tougher, right? So let's see. This is like 2 and okay, let's do like this. This right here is like 6 over 3. So I'm going to pick a number between this and that. So I'm going to pick 6.5 over 3. If you put this right here, 3 and 3 cancel, you get negative 6.5 plus 7, the top is positive. But if you put this right here, this is bigger than 2, so when you subtract 2, it's also positive. The whole thing is positive, so we want that. Now pick a number bigger than 7 over 3, let's say 3. If you put that in here, the top is negative, the bottom is positive, but the whole thing is negative. We don't want that. Therefore, I'm just going to have this for the answer. So if you write it out as an inequality, x is in between of 2 and 7 over 3. as an inequality. But as an interval notation, we write 2, comma 7 over 3, not including the 2, but including the 7 over 3. Just like that. All right, number 29. We have a square root of 3 plus square root of 4 plus, actually, no, just square root of 3 plus 4 square root of x. And that's equal to 5. So how do we deal with this? X is inside, get rid of the big square root by squaring both sides. Cancel. 3 plus 4 square root of x equals 25. Then subtract 3 to both sides, so that will be 22. And perhaps I'll divide the 4 to both sides, so that's square root of x equals 11 over 2. And then square both sides. So x equals 121 over 4. That should do it. Okay, next one, number 30. Ready? 5 is equal to, where is it? 4, 3, 2, 1. 4x plus 3 times 2x minus 1. So, this looks like factors already, but unfortunately the right hand side is equal to 5. So we cannot just say this is equal to 5 or that's equal to 5. No. Multiply this out, make one side equal to 0. So, right here, I will take this times that is 8x squared. And then if we take this times that, it's negative 4x. This times that is 6x. Together we have plus 2x. Finally, this times that is negative 3. Then, minus 5 to both sides. We have 8x squared plus 2x minus 8 is equal to 0. And notice, yeah, this is not factorable, but they are all divisible by 2. So I'm going to divide everybody by 2, including the 0, even though 0. So this right here is 4x squared plus x minus 4 is equal to 0. It's not factorable. You can try. It's not. So, quadratic equation by quadratic formula. Because this is an odd number, if you divide everybody by 4, you will get fractions. Maybe not. X equals negative b, which is the negative 1 here, plus or minus square root. B is 1. Square that, minus 4. A is 4, and c is negative 4. A lot of 4's. Over 2a. 2 is from the formula, and 4 is the a. So we are looking at negative 1 plus or minus square root. Okay, this is 1. And then 4 times 4 is 16. Times another 4 is 64, and that's adding, so plus 64, so together is 65 inside. Oh, that's actually good because we do not have to simplify that because we can't. Now we'll do it. One hour and 30 minutes for 30 questions, so triple that. About 5 hours. Okay, let's do it. Okay, number 31. This one is a little bit, I don't know if there's like a fast way to do it. If you guys do know about a fast way to do it, please let me know. Here we have an equation with 2 absolute values. Not only that, we are saying this plus that is equal to 3. Not only that, this is 1x and this is 2x. it's hard to use the distance argument. If you want to see what I'm talking about, I can make another video for you guys on that. But for this equation, I'm just going to take out the absolute value by considering cases. So case 1, I can say this right here is positive, that's also positive. So case 1 is just going to be positive x. You can just think about it as positive. And then positive 2x plus 1. And that's equal to 3. That's my case 1. And then we can solve that real quick. That's 3x plus 1 equal to 3. Minus 1 is 3x is equal to 2. So x is equal to 2/3. Okay? Not done yet though. Be careful with this. Now, case 2. I will say this is negative. That's positive. So negative x plus 2x plus 1 is equal to 0. Just kidding. 3. Okay, that is x plus 1 is equal to 3. I'm saying x is equal to 2. Okay, so case 1 and 2. Now, case 3. I'm going to say that's positive, but that's negative. So negative parentheses 2x plus 1 is equal to 3. Distribute, so x minus 2x minus 1 is equal to 0. Why am I saying this is all equal to 0? Okay, that is negative x minus 1 is equal to 3. Add 1 to both sides. Divide negative 1 to both sides. So x is equal to negative 4. Now, case 4. I'm saying both of them are negative. So negative x minus 2x plus 1. It's pretty much the opposite of that, I believe. But anyway, I'll just do this. Negative x minus 2x minus 1 is equal to 3. That's negative 3x minus 1 is equal to 3. Add 1 to it, so negative 3x. It's equal to 4. And then, oh, so it's not the opposite of that. Why not? Interesting. Oh, I think, I see why. But anyways, just do it the usual way. And then divide both sides by negative 3, so x is equal to negative 4 over 3. Now, we did all 4 cases, but we have to check, because if we do this, sometimes we end up with extraneous solutions. If you plug in negative 4 into here, we get, let's see, how am I going to check? Right here, this is negative 4 plus absolute value of 2 times negative 4 plus 1. Okay, so that's positive 4 plus, that's negative 8 plus 1 is 7. That's negative 8 plus 1 is negative 7. Absolute value that is 7, but that's going to be 11. So this is not correct. And then if you plug in this into there, so absolute value of negative 4 over 3 plus absolute value 2 negative 4 over 3 plus 1. Okay, that's 4 over 3 plus, that's negative 8 over 3, yeah? Yes, plus 1 is the same as plus 3 over 3. So together, that's negative 5 over 3. In the absolute value though, so it becomes positive 5 over 3. So as you can see, this right here is actually legit 9 over 3, which is 3. So this right here works. Yes, so be super careful. Do not just say all the negatives are bad. And then let's go back to check case. I don't know why I didn't start with case 1 and 2. But anyways, let's check case 1, plugging 2 over 3 here. So I'll just do it real quick. 2 over 3 plus 2 times 2 over 3 plus 1. So that's just 2 over 3 plus, that's 4 over 3 plus 1, which is like plus 3 over 3. So that's 7 over 3. And that's also 9 over 3, which is indeed equal to 3. So this right here also works. Now let's try 2. If we have absolute value of 2 plus absolute value of 2 times 2 plus 1, That's 2 plus 5. That's 7. Right? Of course, it's not equal to 3. So this right here is out. So only this and that are the answers. As I mentioned earlier, I'm not sure if there's an easier way to solve this kind of equations. If you do know, please let me know. But this is perhaps the safe way to do it. All right. Now, number 32. X squared plus parentheses x plus 1 squared plus parentheses x plus 2 squared is equal to 3. Okay, there's no shortcut for this. I don't think so, at least. So I'm just going to multiply everybody and then combine terms and then make one side equal to 0 and so forth, x. So this right here stays. Expand this, we get x squared plus 2 times this and that, so it's 2x plus 1 plus x squared plus 2 times this and that, so that will be a 4x, and then plus this square, which is 4, and that's equal to 3. So now 1, 2, 3, we have 3x squared, 2x, 4x, that's plus 6x, and then that's going to be plus 5, and that's equal to 3. And then, of course, minus 3 to both sides. So that's 3x squared plus 6x. 5 minus 3 is plus 2. It's equal to 0. And again, if I divide everybody by 3, I will get 2 over 3 fractions. So I'm not going to complete the square. I'll just use the quadratic formula. X is equal to negative b, which is the 6. And then plus or minus square root. B squared, which is 6 squared. Minus 4ac, so 3 and 2, over 2 times a. And then this right here is negative 6 plus or minus square root. Okay, let's see right here. That's 36 minus that's 12 times 2 is 24. So the inside is 12. And then over 6. And now for square root of 12, we can break it down as square root of 4 times square root of 3. So that's a regular 2. So here we have this equals negative 6 plus or minus just a regular 2 and then square root of 3. And I would recommend you guys to do the following. Either you write it as over 6, or you just put it as over 6. But then be sure, do not cancel this and that. Factor out the 2, right? Factor out the 2. That will give us negative 3 plus or minus square root of 3. And then reduce this. And then at the end, we get negative 3 plus or minus square root of 3 all over 3. How beautiful is this? All 3's. Now, for the next one, number 33, there is a small shortcut. I want to leave it on the board. We have 2x plus 1 squared plus, minus, actually I'm going to write it down right here. 2x plus 1 squared minus 7, 2x plus 1 plus 10 is equal to 0. This is a quadratic equation. If you expand it, combine terms similar to what we did over there, and then solve for x, it's okay. But this is a quadratic equation in terms of 2x plus 1, because this and that match. We can do it by the tic-tac-toe factoring. Have a look. I'm going to factor it like this. Here, I need to have 2x plus 1, 2x plus 1, so that I get 2x plus 1 squared. Now to get 10, let me use negative 2 and negative 5 because I need to produce the negative 7. This times this, I'm just going to leave it negative 5 times 2x plus 1. This times that. negative 2, x plus 1. Combine, we do end up with negative 7, 2x plus 1. So checks. So how do we factor this though? Well, you look at this, minus 2. So we have, let me write it as 2x plus 1 and then minus 2. And then the other one is 2x plus 1 minus 5. That's equal to 0. Now, make this equal to 0. We look at 2x minus 1 is equal to 0. From here, x is equal to 1 over 2. From here, we look at 2x minus 4 is equal to 0. 4 over 2, so x is equal to 2. So, two answers like that. So take advantage of the inside is the same. So very, very useful. Okay, number 34. Number 34, we have 16, already done in red, raised to this 3x plus 5 equals 8 raised to the 4x minus 27. Exponential equations, you don't need to use logarithms every time because pay attention to the bases. We can actually make them the same base. This is the same as 2 to the 4th power. And the 8 is the same as 2 to the 3rd power. Now multiply the powers. 2 raised to the 4 times 3x plus 5. That's equal to 2 raised to the 3 times 4x minus 27. When the bases are the same, the power here must be the same as that. So we look at, let's distribute this as well. So that's 12x plus 20 equals, distribute, we get 12x minus 81. Now be super careful with this. If I minus 12 to both sides, then this and that will be 0. Good. Minus 20 to both sides. So far so good. But this is equal to 0. 0x technically, if you want. That's equal to negative 101. Does this make sense? No, it doesn't. 0 is not the same as negative 101. Or if you look at this as 0 times x, there's no way for you to have an x value here and then multiply with 0 to get negative 101. So this equation, in fact, it has no solution. Alright, number 35. Okay. X to the 4 plus x cubed plus x plus 1 is equal to 0. So at first, if you look at this, it looks like a very nice equation, but you cannot factor it by grouping, unfortunately. So let's try the rational root test. And one should work, huh? Because, well, actually negative 1 because they're all adding. So have a look though. I will just tell you, if we put negative 1, so I'll just say note. If we have negative 1 to the 4th power, which is 1, plus negative 1 to the 3rd power, which is negative 1, so that's the 0, plus negative 1 plus 1, yes, it's equal to 0. That means x equals negative 1 is a root. So go ahead and do the synthetic division. 1, 1, but 0 x squared, and then 1, 1. Negative 1, put it here, and let's get started. Bring down the 1. This time this is negative 1, put it here. Add, we get 0. This time this is 0, put it here. Still 0, good. This time this is 0, put it here. We have 1. This time this is negative 1. At the end we get 0. Now, be really careful though. This right here, we can factor it. We can get x plus 1 as a factor. Yeah? But how about the rest? From here, this tells us we have x to the third power, and then x squared, and then x, and then no x. I take it back, we can actually do this by factor by grouping. Sorry. This is x to the third power plus 1. It's equal to 0. I'm going to do this by factor by grouping. All right, number 35. So notice here we have 4 terms, and then let's try to do this by factor by grouping. So if you look at the first 2 terms, we can factor out x cubed, and then we can get x plus 1. Good. And if you look at the last 2 terms, it's like, what can we factor out, right? Well, in that case, that's just like factoring out 1. Because this is still x plus 1, which matches with this. So we can say that's x plus 1 on the outside, and then x cubed plus 1 like this, and that's equal to 0. So this right here is x plus 1. Now, this is the sum of 2 cubes. It's factorable, and I'm going to remind you guys the formula. When we have a cubed plus b cubed, this right here equals a plus b times a squared minus ab, and then plus b squared. Okay? And if you have a minus right here, I'm just going to indicate that if you have a minus here, that would be a minus, this right here will be a plus, and this right here will still be a plus. So here, a is the x, b is just 1, because 1 is like 1 to the third power. Factor it by this formula, we get x plus 1, and then x squared, minus this times that, which is just x, and then lastly 1 squared, which is just plus 1. And all that is equal to, oh, I think I killed something right here. Oh no, what happened? Okay. Anyways. Yeah, and this is equal to 0. Now, this and that are the same, but if you want to factor it, you can just say x plus 1 squared, and then x squared minus x plus 1 is equal to 0. Anyways, if you put this equal to 0, x is just equal to negative 1. With a multiplicity 2. So if you want to say that, that's okay with a multiplicity 2, right? Meaning happening twice. Negative 1, negative 1. But right here, this is the standard quadratic equation, right? Just use a quadratic formula. X equals negative, b is negative 1 plus or minus square root of b squared minus 4ac. A is 1, c is 1, all over 2. And have a look. That's positive 1 plus or minus square root. If you look at the inside, that's 1 minus 4, so that's negative 3. And then we have this over 2. Furthermore, notice we have this negative on the inside, so that's 1 plus or minus I on the outside. So we have imaginary solutions for that. And yes, so we have this right here, and then these right here. All right. Oh no, the next one is going to take a while. Number 36, we have 4 over x plus 3 over x minus 2 is greater than 1. So we have done a rational inequality before, so I'm not going to give you guys the wrong approach. I'll just show you guys the right way. I'm going to move the 1 to the other side. So we have 4 over x. Leave some space, you will see why. 3 over x minus 2, and then minus 1, and that's still greater than 0. I'm going to combine all three together. Right here, I need to multiply top and bottom by this denominator, so it's x minus 2. For the second one, I need to multiply by x, so that you see, they have the same denominator. And then for the third one, I'm going to multiply the top and bottom by both. Okay, and now they will all have the same denominator, which is x times x minus 2. For this, I'm just going to distribute it. That's 4x minus 8 plus 3 times x is 3x. And then this is a minus 1. When you distribute, be careful. We get minus x. Minus minus becomes a plus, and then a 2. So if you look at the top, 7x minus x is 6x. Then that is minus 6 over x times x minus 2 is greater than 0. And you can actually factor out the 6. Doesn't matter that much though. So let's see, 6x minus 1 over. It's easier to see what numbers that we care if you do factor out the 6, right? Perhaps I'm going to do that right here to save some space. So that's 6x minus 1. Now, let's go ahead and look at this and then find out the numbers that we care. Firstly, pay close attention to the denominator. X cannot be 0, x cannot be 2. Yeah? So we care about 0, we care about 2, cannot be 0. Here, x1 is also a number we care. But here we are not including that either, because the inequality is just a greater than. So we have these numbers. Hold on. I'm checking my answer key along the way. Something's wrong. Okay. I know. Sorry, let me redo it again. I forgot to multiply this by x. I'm very sorry. So I'm going to redo this again. All right, number 36. This is a rational inequality, which we went over the wrong way to do this. So I'll just show you guys the right way to do this. Move the 1 to the other side. So start with 4 of x. Leave some space. You'll see why. And then write this down. Leave some space, and then minus 1. And that's greater than 0. Now, combine all three terms. Get a common denominator. For this, I need the x minus 2. For this, I need the x, so that they have the same denominator. Now for the last one, I will need both of these, x and x minus 2. So x and x minus 2. Now everybody will have the same denominator, which is x minus 2. For this, I'm just going to distribute it. We get 4x minus 8, and then we add 3x. And then right here, make sure you take the negative x, and this is the negative x, and then distribute it. So we will get negative x squared, and then negative, right? And that's an x, so it's a plus x times that, which is 2x. That's still greater than 0. Now, if you look at the top, we have negative x squared, and then 2x, 3x is 5x, and then that is 9x, and then minus 8 over that. Still greater than 0. Now for the top, we can first factor out negative, because usually we like to have the x squared term being positive. So that's x squared minus 9x plus 8. Factor this, we have the negative on the outside, and then we get x minus 1, x minus 8 over x times x minus 2, and then that's greater than 0. Now, you have two ways to go about this. You can divide both sides by this negative and flip the inequality. That might be easier. So I think I'm going to do that. right? Or you can just leave this right here and then just deal with the sign chart later on carefully. Either way, it's fine. So because of this negative, divide both sides by -1, we get, I'll just write it down right here. We have x minus 1, x minus 8 over x and x minus 2. We will have to switch the inequality to be a less than. So this is what we are looking for. Now, find the numbers that we care. From here, we care about 1. From here, we care about 8. From here, we care about 0. From here, we care about 2. And none of them is included because not only the inequality, but of course, this and that on the bottom. So inequality and all that. Okay, here we go. Smallest is 0, 1 next, 2 next, and then 8 last. Open, 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 open. Okay, pick a number less than 0, that's a -1. Do it in your head. This right here will be negative times negative over negative and then another negative. So altogether it's positive. We don't want that. We want negative. Now pick a number, let's say 1/2. 1/2 right here is negative, still negative, but here is positive, and then here is negative. So altogether it's negative, so we want this. Pick a number, and you might be thinking that, do they always alternate? To be honest, if they are all to the first power, yes, but I'm going to show you guys a good habit. Only when you have the square, you have to be careful, but anyways. Here, pick a number, let's say 1.5. Positive, negative, positive, and negative. Altogether is positive, we don't want that, so pick a number here, let's say 3. Positive, negative, positive, and positive. But we have one negative, altogether will be negative, so we want this. Lastly, if we try 9, positive, 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 so altogether they're all positive. So we want x to be in between of 0 and 1, or we want x to be in between of 2 and 8. Interval notation, going from 0 to 1, not including these endpoints, union 2 to 8, not including the endpoints. So just like that. Okay. Number 37, log base 2 x plus 5 minus log base 2 of 4x plus 1. Okay, if you see 1, 2, 4, 5, then of course this is equal to 3. Now, 2 logs, no, we want to combine them to just 1. Here is a minus. So we combine them, we do this divided by that. So that's log base 2 of x plus 5 over 4x plus 1. Then we do 2 to this power, 2 to that power, so they cancel. So here we have x plus 5 over 4x plus 1, and that's equal to 2 to the third power, which is 8. Now, this is a rational equation. It's an equation. You can really just multiply this to both sides. So it looks like we have x plus 5 equals 8 times 4x plus 1. This is legit. If it's an equation, no worries. And then just do the usual business. So we get 32x plus 8. And then minus 32x to both sides. And then minus 5 to both sides. So that's negative 31x equals negative 3. And then divide this to both sides. So divide negative 31 to both sides. X is equal to positive 3 over 31. And that should do it. And that's indeed 2 over 11. That's on my insert key. Okay, something's wrong again. I have 2 over 11 on my answer key. If you guys want to see that, I don't know why, so I'm going to check real quick. 2 over 11. How is that 2 over 11? Two x plus 2x plus 5. No, this is correct. I believe this is correct. I think I make a mistake on my answer key. Let me just double check. Oh. I did make a mistake in my work though. Even though my answer key I think it's wrong, but this right here is also wrong, so I'm sorry about that. Okay. Oh, let me redo it again. You guys know how I want to do it. Alright, number 37, we have two logs and it's a minus, so combine them. This right here is log base 2, and we do this, which is x plus 5, over that, which is 4x plus 1, and that's equal to 3. Then we do 2 to this power and 2 to that power so that they cancel. So here we have x plus 5 over 4x plus 1, and that's equal to 2 to the third power is equal to 8. Now we have a rational equation, so we can just multiply this to both sides without any worry. Okay, x plus 5 equals 8 times 4x plus 1. And then solve it. X plus 5 equals, distribute this real quick of course, that's 32x plus 8. Now move 32x to both sides like this, and then minus 5 to both sides like this. That is negative 31x, and that is positive 3. Now divide this to both sides, so x equals negative 3 over 31. And that's the answer. And then I'm going to make a little mark on my answer key. Yeah, so, okay. Now, for the next one, let's solve a tangent equation. I'm going to move this a little bit. Minus, and then we have log base 2 of 4x plus 1. Okay, number 38. Here we're going to solve a tangent equation for the first time. We have tangent of 3x is equal to 1. How do we solve this? Well, here's the deal. You can call this to be the angle theta. Just think about it as the angle theta because you have to get 3x. Yeah. So if you think about it, if you have tangent of an angle is equal to 1, you can look at this as 1 over 1 if you want to use the reference triangle method. This means you look at the y over x value. You take y to be 1 and x to be positive 1. If you look at the triangle, x is 1, it's like this, y is 1, it's like this, then you see this angle is 45 degrees, so that's pi over 4. Okay? But this is not the only way to get 1, because this time we're talking about we are talking about y over x. They can both be negative. So I can say y is negative 1 and x be negative 1, because negative 1 over 1 is still equal to 1. Okay? So actually I'm going to write it like this, perhaps it's more clear. Tangent is 1 over 1. I can also look at this as negative 1 over negative 1. If you look at it like this, again, this is y, this is x. X is negative 1 is right here, y is negative 1 is right here. So this angle is pi over 4. But you go from here to here, it's 5 pi over 4. But the truth is, you see, they will line up to be on the same angle. right? A straight line means straight angle. So here's the deal. Tangent of 3x is equal to 1. Look at the angle theta, which is the 3x. So you can just say 3x, which is the theta. Okay? The first answer is pi over 4. And in fact, when you are solving a tangent equation, as long as you know one answer, the next answer is just going to be you add pi to it. And you can keep adding pi or subtract pi because the period for tangent is pi. So right here, we just add n pi. Okay, n pi because of this idea. Now, I'm going to erase the theta. Oh, I will still keep the angle theta here. Okay. I want to get the x by itself. So what we can do is just multiply both sides by 1/3. So that they cancel, I get x equals 1/3 times that, pi over 12. 1/3 times this, plus n pi over 3. Just like that. So even though the angle inside is like 3 times something, but sometimes it's not so bad. Only when you have multiple trig functions, then you have to make sure that they have the same angle. Sometimes that might be more difficult. Okay, so far so good. That's only 38 questions. I'm going a little bit slower than I was expecting. And then, yeah, I spent a very long time to come with all these questions, and some of the questions are longer than the others. Like for the next one, that's 39. Cubic equation. X cubed plus 3x. I have a square. Good. Minus 4x is equal to 0. So for this right here, we can do it by factoring. Factor out an x first. And then we get x squared plus 3x minus 4 equal to 0. Then factor this quadratic the usual way. X plus 4, x minus 1. So we're pretty much done. This right here. Don't forget, x is equal to 0. You have to account for that. From here, -4. From here, 1. So 3 answers. Done. Now, number 40. System of equations. We have x plus y equals 1500. And then the other one is 0.08x plus 0.04y equals 95. So this kind of equation is actually from like the application of system of equations. You have the sum is equal to something, and then like a percentage of individual add them together is equal to something else. But anyways, you can do this by elimination, or you can do this by substitution, up to you. I will do this by elimination. I'm going to eliminate, let's do y. So LCM, the coefficient should be 0.04. I'm going to multiply the top one by negative 0.04. And then the bottom one doesn't matter. This times this, negative 0.04x. This times this, negative 0.04y. This times this, negative 60. And then the second one, just write it down the same. Now, we add them. This and that cancel. This right here is 0.04x, and that's equal to 35. And then divide both sides by 0.04. 800 something. Just going to take a look. 875. So x is equal to 875. And then x plus y is equal to 1500. So minus 875. Y equals 625. So here's the x, here is the y. Done. Okay, 40% done, kind of. Because you know there's always going to be a question number 101. Next one is a cubic inequality, number 41. So x cubed minus 5x squared is greater than or equal to 4x minus 20. Alright, for this, again, let's make one side equal to 0 and then factor it and then talk about the numbers that we care. Put this to the other side. X cubed minus 5x squared minus 4x plus 20 is greater than or equal to 0. Now, for this kind of questions, most likely it's going to be factorable because otherwise it's going to be really long. It is factorable. Here, we can factor out x squared, and then we get x minus 5. And remember, when we factor, this is a minus, so put that down right away. And if you look at 4 and 20, we can factor out 4, and then we end up with x 20 divided by negative 4 is minus 5. Factor that out, and then we have x squared minus 4 is greater than or equal to 0. Factor this, x minus 5, and then x minus 2, x plus 2 is greater than or equal to 0. Now, find the numbers that we care. From here, we care about 5 to negative 1. And here's a secret. If they are all to the first power, you know the signs will alternate. Anyways, negative 2 go first, 2 next, 5 last. And this time, because of the greater than or equal to, we are all going to take the numbers. Okay, let's at least do 1, right? Pick a number less than negative 2, let's say negative 3. Plug into here, that's negative. Plug into here, that's negative. Plug into here, it's negative. So all 3 negative. No. And then I'll tell you, this right here will work, not this one, this right here will work. Okay, and you can try that. You can just double check on that. So here, we will have x is in between of negative 2 and 2, or this right here is x greater than or equal to 5. So as an interval notation, negative 2, 2, including the endpoints here, union, including the 5, all the way to infinity, and we never include infinity. So this right here will do it. All right, number 42, a little bit strange. 1 over ln of x plus 3 is equal to 2. Don't worry, we can still multiply this to both sides. It's an equation, very nice. So this is 1 equals 2 times ln of x plus 3. Now isolate the ln part, divide the 2 to both sides. Let me write this down first though. That's equal to 1/2. Then we do e to the power, so they cancel. X plus 3 equals e to the 1/2 power. Let me write it like this. Still e to the 1/2 power. But the 1/2 power is the same as the square root. Square root of e. And then minus 3 to both sides. Done. So still works. If you leave that as like a 1/2 power, that's fine too. Right, number 44. Here we have an absolute value inequality, but this time it's a greater than case. We have gone over the less than case already. Here's 3x plus 5 in the absolute value, and then minus 6 is greater than or equal to 14. So add a 6 to both sides. Absolute value of 3x plus 5 is greater than or equal to 20. Now, if it's a greater than or equal to case, you have two numbers you care and then you go out because you want the distance to be bigger than whatever that is, right? That's what we talked about earlier. If it was less than, you take the middle. If it's greater than or equal to, you take the outer pieces. So you have two parts. So once we get rid of the absolute value, first I'm just going to say 3x plus 5 is going to be less than or equal to negative 20 for this direction, right? I'm not saying this is like negative 20. I'm just saying that you have to go all the way to the left and then consider the negative. And then the other piece is you just take it out, and then you still have the greater than or equal to 20, just like that, okay? And then just solve them individually, subtract 5 to both sides, divide 3 to both sides, so x is less than or equal to negative 25 over 3. And the other one is 3x greater than or equal to 15, x is greater than or equal to 5. And this is an OR situation with two pieces. So this one, we started at negative infinity, go up to negative 25 over 3, including this, but never including infinity. Union 5 to infinity, including this, but not infinity. Done. All right, fun one. 2 to the x plus 2 to the x plus 1 is equal to 5. How do we solve this though? Here's the key. 2 to the x. 2 to the x plus 1. The exponents are adding, so what can we do? Well, if they are adding, we can break it apart. Check this out. This right here stays. This right here we can look at it as 2 to the x times 2 to the first power. Because when they multiply, we add the exponents, just like that. So now if we have a sum in the exponent, we can break it apart like this. That's equal to 5. Now, this is like saying 2 to the x plus, I will put a 2 in the front, and then 2 to the x. How many 2 to the x do we have here? Just one of them. And then we have 2 more of the 2 to the x. So together we have 3. 2 to the x. It's a multiplication. Now, divide the 3 to both sides. I need to get the x by itself. We can use logarithm. Log, the same base, 2. So take log base 2 to both sides. Cancel, cancel. X equals log base 2 of 5 over 3. And then we are done. Just like that. Right. Next one, number 46. Square root of 3 times sine of x, and then plus cosine of x is equal to 0. Sine, cosine, we have two different trig functions, but thankfully this is just equal to 0. We can actually just make it into one trig function. Have a look. I can move this to the other side first. So square root of 3 times sine x. Let's do that, yeah. This is equal to negative cosine of x. Now move that first. And then we can divide both sides by sine x or cosine x. It's kind of up to you. So I think I'm going to do this. I like to work with tangent better. I am going to divide both sides by, let's do this first. Sorry. All right, number 46. Square root of 3 times sine x plus cosine x is equal to 0. Sine and cosine, two different trig functions. No good. But if I look at this and divide everybody by cosine x, this right here is just square root of 3 times tangent x plus 1, and that's equal to 0. Now we have just a trig equation with one trig function. Keep this, I can move this to the other side. So tangent x will be negative 1, and then divide this to both sides, so we have negative 1 over square root of 3. Now, if we can find one answer, remember when we have a tangent equation, once we get one answer, we were pretty much done. This right here, which one do we do though? Because right here we have y over x, right? So we can say y is equal to -1 and x is equal to square root of 3. That's fine. But the truth is, you can also put a negative down here. I'll tell you it doesn't matter. It doesn't matter. So here's the deal. I'm going to draw a picture for you guys right here. X is square root of 3, so I'll put it down right here. So this portion is square root of 3. Y is -1, so it's down here, -1. Yeah? So here, special triangle. This right here is going to be 30 degrees, which is pi over 6. But if you measure from here all the way to here, we do 2 pi minus pi over 6, and that's like 12 pi minus pi is 11 pi over 6. So if I did it like this, it's actually not the first positive answer that will give me this answer. Okay, so what can we do? Just real quick. Because we can also look at it as 1 over negative square root of 3, and then look at this as the y, and look at this as the x, and then draw this picture instead. Y being 1, x being negative square root of 3. And look at this right here as our reference triangle. This right here is still pi over 6, and as I told you, they will line up on a straight line. So in this case though, from here to here, you are going to just do pi. You are going to do pi minus not much, which is 6 over 6 here. So that's together 5 pi over 6. So just to make it look nicer, I will start right here. I will say x equals 5 pi over 6. Starting right here. If I add pi to it, I'll get here, right? So I just have to add n pi, because I can do this as many times as we need to. And this is it. And this is it. Is it possible if you start with 11 pi over 6 and add n pi to be the answer? Yes, if you write that down, that will also be correct. But usually, we like to start with the first positive answer that makes this true. So that's why I will start right here. Okay, 2 sides done. Yay. Okay. All right, how are you guys doing? So far, we have done 46 equations. All right, 2.5 hours. Okay, that's going to be more than 5 hours. Okay, let's see. Number 47. Another system of equations. 4x plus 6y equals 5. 6x plus 9y equals -2. All right. Let's get rid of y. I don't know why. Don't ask why. I will just get rid of y. Lowest common multiple of 6 and 9 be 18. For the top equation, I will multiply everybody by 3. 3 times 6 will be 18. For the second equation, I'll multiply everybody by -2. So that will be 18, and then the signs will be negative and positive, right? So 12x plus 18y is equal to 15, and then minus 12x. You guys see it? That's 4. Our goal is to get rid of the y, and yes, 0, but 12x minus 12x, it's also 0. Be careful though, we still have to pay attention to the right hand side. 15 plus 4 is 19. Is this true or false? This is always false. So you conclude that this system of equations has no solution. If you end up with 0 is equal to 0, which is actually a true statement, and notice the x doesn't matter anymore, then this right here will give you infinitely many solutions, right, for system equations. So just keep this in mind. Okay, next one, number 48, another log equation. Log of 64 and then 5x minus 1 is equal to 2 over 3. You can totally tell that I wrote this question 1, 2, 3, 4, 5, 6. 64 to this power, 64 to that power, cancel, cancel. The main thing for this question is really to see if you know the rational exponent. How do we deal with this? Firstly, the over 3 turns into a cube root. And then I would recommend you guys to do the cube root of 64 first. And then after that, square that. Because this way the number inside will become smaller, which is 4, square that, and you just end up with 16. Okay, so 5x minus 1 is equal to 16. Add 1 to 17, divided by 5, 17 over 5. Just like that. You know, when you're doing like question number 22 or so, it's like, this is impossible. But once you are approaching 50, once you are approaching halfway, it's like, oh yeah, we are almost halfway there, and then I can see it. Anyways, number 49. Okay, log base 2 of x plus log base 2 of x plus 6 is equal to 4. You know, I just recall that I think I had a bad habit like earlier for the log equation. I might not have checked the solution for question number 37, so I'm sorry about that. We should have. It's all positive, so that was okay. And then, oh, yes, oh no, for number 26, I forgot to check the solution. So, I'm sorry, correction for number 26. When we had log 2x plus log 2 of x plus 1, I said it was equal to 5, and then we got x is equal to minus 1 plus or minus square root of 129 over 2. We have to get rid of the negative. Sorry about that, because negative negative, we cannot put that inside a logarithm. So I'm sorry for number 26. But for this one, I'm going to remember. Alright, so similar question. I'm going to just multiply the insides together. So x, and this is a sum, so multiply with x plus 6. That's equal to 4. So do 2 to this power, 2 to this power, this and that cancel. Distribute in the meantime. X squared plus 6x equals 2 to the 4 is 16. So x squared plus 6x minus 16 is equal to 0. Factor it, x plus 8, x minus 2 is equal to 0. X equals negative 8, x equals 2. Be careful. If you put negative 8 into this x, it's not going to work. So get rid of that. Because again, log of negative number, that's not real. Right? But when you plug in 2, the insides are positive, so that's legit. Right? So go back to number 26, get rid of that negative in the answer. For number 37, though, it was okay because everything is not to be positive, so that was good. Okay, number 50. Okay, let's see if I can fit in here. Negative 12x plus 3 times. No, I'm not going to be able to fit that in. So Okay, we have negative 12x and then plus 3 times 4 and then plus 5x, and you know the answer. You know the question already is 1 through 9, but the answer is 9 equal to 0. I will tell you that because I did a 0 already. 6, 7 over 8 minus x and then plus 9. Okay, 1 through 9. So pay attention to the parentheses if there's anything in front. Distribute. So negative 12x distribute is plus 12 and then plus 15x. That's equal to distribute. Okay, 6 times 7 over 8. So 6 over 1 and then reduce by 2. So 3 and 4. So that's 21 over 4 and then minus 6x and then plus 9. Okay, I will just deal with the fraction. If you want to multiply everybody by 4, the numbers might be too big, but anyways. This and that is 3x and then plus 12. And this and that, okay, 21 over 4 plus 9. So that's 36. So that's 57. So negative 6x minus, plus 57 over 4. Something's wrong. Oh, I had the wrong answer in the answer key. Let me just double check. I thought when I was creating this question, I wanted to make it no solution. But I think maybe when I was writing the question, I did something wrong in the computation. So that's why yeah. Because in order for this to have no solution, I should have a negative 6x here. But I don't have that. So this is my original question. Okay. So nothing wrong with this. We can still solve it. It's just I have a mistake on my answer key. So let's just continue. So this and that is 3x, this is 12, and then this is negative 6x, and then 21 over 4 plus 9 is 57 over 4. Okay, and then let me just double check. Divided by 2. Alright, now I'm just going to add 6x to both sides. Yes, and then minus 12 to both sides. So this right here is 9x equals, alright, 57 over 4 minus 12, which is the same as minus 48. So that's minus 9 over 4. Yes? Yes, 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 yes. Yes. Okay, and then 9x is equal to negative 9 over 4. I'm just going to multiply both sides by 1 over 9. It's easier to look at it like this, so you can cancel that. And then you get x, it's equal to reduce out the 9, so it's negative 1 over 4. It still ends up to be a pretty nice answer, it's just not no solution. But anyways, let me just write that down real quick. Okay. Alright, half done. So is this like 6 hours? 2 hours and 40 minutes. Right, number 51. Cosine of some input stuff, like 3x plus pi is equal to 0. So now we just have a cosine function. So look at this as like an angle theta, and then just think about cosine theta is equal to 0. So just think about this for now. And when is cosine going to be 0? It's a special number, right? 0, remember 0, 1, and -1 for sine and cosine, they are special numbers, so refer to the unit circle. Cosine is the x value. It's 0 here, and it's also 0 here. Starting at pi over 2, and then you can just add pi to get to 3 pi over 2. And then, of course, you can go back and forth. So, we want this thing, so I'll write down 3x plus pi to be equal to, starting at pi over 2. Do not add 2 and pi, because we can just add pi to get to the next place that we need. So just add n pi. So again, this is one of the special cases that for cosine, you don't see the 2 and pi part. Right, so just remember the idea. Now, I'm going to just minus pi to both sides. So that's 3x equals pi over 2 minus pi. It's like 1/2 minus 1 is -1/2. So it's negative pi over 2. This right here stays. And then at the end, we divide everybody by 3 or multiply everybody by 1/3. That's x equals, this times that, negative pi over 6 plus n pi over 3. Done. Okay, number 52. I am going to attempt to see if I can fit in here. Okay, if you can see my number 52, you'll see number 52 is the equation and number 53 is the same thing but with inequality. Okay, x plus 1 over x plus 2 plus x plus 3 over x plus 4. For this one, we just want this to be equal to 2. It's an equation, so we can do whatever we want, like almost. Do not multiply both sides by 0, never. But we can multiply both sides by this and that. So x plus 2, x plus 4. So if we take this, multiply that, this right here stays. But this and that cancel, I still have x plus 4. Continue, this and that cancel, but this stays. But this right here, I need. And then finally, this times that, so it's plus 2x plus, is equal to 2x plus 2x plus 4. And then just multiply this out. So this right here, it's x squared, and then that's 4x, and then another x, so it's plus 5x, and then plus 4, plus x squared, plus 2x, plus 3x, so it's plus 5x, and then plus 6. And for this, it's going to be, let me make it clear, this times this is x squared, 2x, 4x, so that's 6x, and then plus 8. And then we still have the 2 in front. So 2 times this is 2x squared plus 12x plus 16. Okay, and then that's just, I'm going to just do the usual thing. So on the left hand side, this is 2x squared, and then this is plus 10x, and then this and this is plus 10. Alright, 2x squared on both sides, they cancel. So I will still show you guys all that. Cancel. Minus 12x. Cancel. And then minus 16. Well, actually, no, because the x squared term is gone. So I'll keep the 16 here. So this is gone. I will have minus 10 here, minus 10 here. So this does not cancel. Have a look. That is negative 2x equals 16 minus 10 is 6. And then divide both sides by negative 2. Yeah, x is equal to negative 3. And will this make the denominator 0? No, because right here we are saying x cannot be negative 2, x cannot be negative 4. These are the two restrictions for this equation, but here we are saying x is equal to -3. It does make the top equal to 0, that's fine. If the top is 0, the bottom is non-zero, the whole thing is 0, so this is fine. So x equals 3 is the answer for that. Now, for the next question, it's another rational inequality, but I just changed the equal sign to a greater than sign, so 53 x plus 1 over x plus 2 plus x plus 3 over x plus 4 is greater than 2. In here, make sure you do not multiply the denominators to both sides. No. So, what we are going to do is, we're just going to combine all the terms. Put this to the left hand side. Leave a space, plus x plus 3 over x plus 4, and then minus 2. And there's no way for me to fit in, so I'm going to erase all this now. So, minus 2, blah blah blah, and it's greater than 0. Get a common denominator. Here, I need the x plus 4. And then do the same thing here. Here, I need the x plus 2. And then make sure you put parentheses around them as well, because later we have to FOIL it. Here, we need both x plus 2, x plus 4, and then x plus 2. Okay, now I'm just going to put them all together. X plus 2, x plus 4. Okay, expand this. X squared plus 5x plus 4. And then we add, expand that, x squared plus 5x plus 6. Okay, here again, let me just make it clear for you guys. That's a negative 2. And then this is x squared plus 6x plus 8. So if you distribute the negative, it becomes negative 2x squared minus 12x and then minus 16. And then all that is greater than 0. The good thing is that this and that cancel, so we don't have a quadratic part on the top, but this 10 and then minus 12, so we have negative 2x, and then furthermore 10 minus 16, which is minus 6 over x plus 3, x plus 4, and that's greater than 0. And again, we can factor out the negative 2. So perhaps I'm going to, okay, I'm just going to do it right here, negative 2, and then we get x minus, so x plus 3, because we factor out negative 2. Now, I'm going to use this negative to turn that into a less than. So we are going to get 2 parentheses x plus 3 over, no, this is plus 2. This is x plus 2. And this is x plus 2. And then factor out x plus 3, and then this is x plus 2, x plus 4. But this negative I divided to both sides, so this will become a less than situation. Okay, now, what do we care? From here, we care about negative 3. From here, we care about negative 2. From here, we care about negative 4. And then pay close attention to this one right here, right? Number line, negative 4, negative 3, and then negative 2. It's a greater than, so none of them is going to be included. So open, open, open. So as you can see, if you have the equation, you just have to care about x cannot be negative 2 and x cannot be negative 4. And you just make sure that they don't appear on your answer. But for inequalities, you have to care about that. Okay. Pick a number less than negative 4, let's say negative 5. Put it here, is the 2 is positive, so it doesn't matter. So negative, negative, negative. So altogether is negative. So we want it because this time we want the less than 0. And then I'm going to leave the rest to you guys. The rest is this and that. Again, if you have first power, once you know one, they alternate if they are just to the first power. No quadratic here either. Okay, so that's the quick way to do it. So from here, we can say x is less than -4, or the other way, or this one, x is in between of -3 and -2. Interval notation. -infinity to -4, not including union, -3, -2. Just like that. Okay. Seriously, who likes like rational inequality, right? It's like almost nobody, I will say. But there's like, oh, anyways, let me just focus and then do it. Okay. Number 54. Seven times the cube root of 2x plus 5 plus another 5 is equal to 19. Alright, so here we have a radical equation and this is a cube root. I isolate this part first because the x is only inside of that. So -5 to both sides. 7 cube root of 2x plus 5 is equal to 19 minus 5 is 14. Divide the 7 to both sides. Well, that's cube root of 2x plus 5 is just equal to 2, right? 7 divided 14 divided by 7 is equal to 2. Now, to get rid of the cube root, we raise both sides to the third power. This and that cancel. 2x plus 5 equals 2 times 2 times 2, we get 8. Minus this to both sides, we get 3. Divided by 2, x is equal to 3 over 2. This will work. You can plug in and try, so it does work. Next one, number 55. It might look a little bit scary, but it's not bad. E to the 2x, and then plus 2e to the x minus 15 is equal to 0. How do we solve this? Notice that this is e to the x. This is e to the x and then squared. So this is actually a quadratic equation, but in terms of e to the x. So we can solve this by factoring it. It's factorable. We need e to the x times e to the x to get e to the 2x, and then to get -15, 5 and -3. Have a look. This times this, -3e to the x. That's an x. This times this is 5e to the x. Together, we do end up with 2e to the x. So this means we factor this, e to the x plus 5 times e to the x minus 3 is equal to 0. Now, be careful though. We put this equal to 0. So that means e to the x is equal to -5. If you take natural log to both sides, does that work? No, no real numbers. So this right here, this part, no real solutions. Can you solve it with complex numbers? Yes, you can watch my other videos for it, but for now, remember, we're just solving non-real solutions for polynomials only. For exponential solutions, no, we don't do that. Especially if it's just in precalculus, we don't do this, just say no real solution. So we just don't consider that. But for this, e to the x minus 3 is equal to 0. E to the x is equal to 3. Take the natural log, both sides. X equals ln 3. That's the only answer. Oh, okay. So number 56. A system of equations. Here we have 3x plus 2y. It's equal to 5. And then 2x plus 3y. It's equal to negative 10. So don't ask why. I'm going to get rid of y. 2 and 3, so the lowest common multiple is 6. So right here, let's multiply everybody by 3. But for the second one, let's multiply by not just 2 though, we want negative 2, so we can get negative 6y. So we will see the top is 9x plus 6y equals 15. The bottom is negative 4x minus 6y equals positive 20. Cancel, add them up. 5x equals 35. So divide both sides by 5, x is equal to 7. Put that in the first equation. 3 times 7 plus 2y is equal to 5. So that's 21. Plus 2y is equal to 5. So 2y equals 5 minus 21 is negative 16. Divide both sides by 2, y is equal to negative 8. So 7 and negative 8. Yes. Now, number 57, absolute value equation. Absolute value of 4x plus 3. This time it's not just equal to a number, but rather we have 2x. So be super careful with this. Still, we can take out the absolute value and it's just equal sign, so just do the plus or minus. Right here, I'm just going to do 4x plus 3 equals 2x. Just take out the absolute value. Right here, 4x plus 3, I will make it negative 2x and then see what happens. Okay, move this to the other side. So 3 equals negative 2x, divide both sides by negative 2. That's what we have. Now for this, move this to the other side. Divide both sides by negative 6. X is equal to negative 1/2. Box? No. Wrong. Why? Because if you put negative back here, you will get absolute value of something equals 2 times negative 3 over 2. Absolute value cannot be a negative number. Likewise, if you put this right here, absolute of whatever equals 2 times negative 1/2. No good either. So this equation actually has no solution. You answer them as no solution. You can also look at the graph of it. I'll leave that to you. All right, number 58. We are going to solve a exponential equation, but with different bases. And the worst thing is that we cannot make the bases the same with the usual trick that we did in this video. Like we cannot say okay, 3 is what times what. No, anyway. Number 58. Number 58, 5 to the x is equal to 3 to the x plus 2. We cannot break it down like 16 and 8, 2 to the 4th power and 2 to the 3rd power, right? No. This right here, we can do the following. Check this out. X plus 2 in the power, I can break it apart. This is 5 to the x equals 3 to the x times 3 to the 2nd. Yes, because usually we look at it backwards, right? When we multiply them, we add the exponents. So if the exponent is being added, we can break it apart. So now, this is 5 to the x equals 3 to the x times 9. This is where we have the x, likewise that. I'm going to do this. I'm going to divide both sides by 3 to the x. This and that will cancel, no problem. And then 3 to the x is never 0, so we are not dividing by 0, so don't worry about that. Right, this is not equal to 0, so just indicate that. Because you should be careful when you divide both sides by an expression that has x, so be really careful with that. But this is not equal to 0, so we are okay. Here though, both of them have x, so I can write it as 5 over 3 raised to the x power. Because usually when we have this, we go back, but when we have this, we can do this. That is equal to 9. Now, we have a number to the x power, it's equal to a positive number, so we can just go ahead, take log of the same base, which is 5 over 3. Let's do that right here as well. The base is legit. It's a positive fraction. It's totally legit. You cannot take log base 1. You cannot take log base of a negative number. Log base of 5 over 3 is totally okay. This and that cancel. You do get x by itself. Log base of 5 over 3 of 9. Just like that. And if you want to know the approximate answer, this right here is about 4.301 if you use a calculator, and also maybe the change of base formula, etc, etc. I will leave that to you guys. Number 59. Square root of 3 sine x and then minus cosine x is equal to 2. Now, for this one, I'm going to show you guys this way, which is really cool, so check this out. Sine and cosine, this time, the right hand side is not equal to 0. So if I divide everybody by cosine, we'll get tangent, and then minus 1, but we will end up with like secant. So I'm not going to divide, but instead I'm going to do this. I'm going to divide everybody by 2. Why? Have a look. This right here is square root of 3 over 2, and then sine x minus 1/2 cosine x, and this is equal to 1. Now, pay attention to this and that number. They are familiar, right? From the unit circle and all that stuff. Have a look. If you recall, maybe we can use the 30, 60, 90 special right triangle. Let's look at the pi over 6 right here, which is 30 degrees. That means this is 1, this is 2, and this is square root of 3. So, if you look at square root of 3 over 2, I'm going to purposely write this as cosine of pi over 6. Can we do that? Yes, of course, because cosine of pi over 6 is square root of 3 over 2. And then continue with that multiplying with sine x, and then minus 1/2, guess what? We can look at this picture and say that's sine of pi over 6. Very nice, huh? And then we have cosine x is equal to 1. Now, what good does this do though? Well, I'm going to tell you guys that when we have sine of an angle times cosine of the other, and then sine of the other times cosine of that angle, this is the angle difference formula for sine. I'm going to write it down for you guys. So note, when we have sine of two angles, A minus B, we get sine of the first times cosine of the second minus sine of the second times cosine of the first. So, of course, I'm going to use this. Sine x cosine pi over 6. So, this is the A, that's the B. This right here is the A, and that right here is the B. This right here is the B. This right here is the A. So, altogether, look at it backwards, we will just get altogether sine of A, which is x, and then minus pi over 6. So this is how we can combine them into just one trig function. That's what I told you guys. Whenever you have a trig equation, try to work with one trig function. And that's this part, and the right hand side is still equal to 1. Now, think about sine of where will give us 1. On the unit circle, 1 is right here. which is pi over 2. So that means the input here must be pi over 2. So we must have x minus pi over 6 must be pi over 2. And this is the only place on the unit circle that will give a sign of that angle being 1. So the next time you want to get to this point here, you will have to add 2 and pi. Okay? Then to get x by itself, just go ahead and add pi over 6 to both sides. Cancel. So ladies and gentlemen, x is equal to, okay, pi over, it's like 1/2 plus 1 over 6. So we need a 3 and 3, so that's 4 over 6, which is 2 over 3 with the pi, so 2 pi over 3 and then plus 2 and pi, just like that. And that's the correct answer on my answer key as well. So this is it. Number 59. Okay. Alright, number 60. Here we have 16 over x. And then minus 18 over x minus 1 and plus 2. Now it's equal to 0. So for this one, we can just move the 2 to the other side and multiply everybody by the lowest common denominator. Well, actually, we don't need to do that. We can just multiply everybody by the lowest common denominator right here. Doesn't really matter. Yeah, so 3 things on the left hand side. Do this. We can do this again because this is just an equation. Take this times that, x cancel. 16 stays, but we multiply that with x minus 1. And then minus 18. This and that cancel, but we have the x. Then plus 2. We need both of them. Ooh. Almost got it wrong, otherwise I have to redo it. This time 0, 0. Now distribute. So that's 16x minus 16 minus 18x, that's plus 2x squared minus 2x equal to 0. Write down the 2x squared term first, and then this and that is negative 2x. Oh, and then one more. So it's minus 4x. And then minus 16, it's equal to 0. And right here, I'm just going to divide everybody by 2. And this is an equation. We can just divide the 2 throughout. So we get x squared minus 2x, and then this is minus 8. It's equal to 0. Can we factor this? Yes. X minus 4, x plus 2. From here, x can be 2, x can be 4. From here, x can be negative 2. Here we are saying x cannot be 0. Here we cannot have 1. But 4 and negative 2, they are totally legitimate. So these two are the answers. Alright, for number 61, I can actually fit in here, so I will fit in here. Number 61, we have this 3x. Actually, no, I'm just going to make it prettier for you guys. I'm going to erase this part right here, because I want to do number 61, number 62 together on the board for you guys. Okay, number 61, 3x plus 1 squared is equal to 9. And then, for number 62, 3x plus 1 squared is equal to 9. X. So they are different. Which one's easier? That one. When we have a perfect square, it's equal to a positive number, or any number, you can just take the square roots to both sides, and don't forget the plus or minus. So we get 3x plus 1. the first case is positive 9, so I'm going to just indicate that we have two cases. 3x plus 1 equals positive square root of 9, which is 3. And the other case is 3x plus 1 equals negative 3. Solve this, minus 1 to both sides, we get 2, and then divided by 3, x is equal to 2 over 3. Here, minus 1 to both sides, negative 4, x is equal to negative 4 over 3. And wait. Negative 2 over 3, I got it wrong for some reason. Why did I get my answer key wrong right here again? If you guys look at number 61, I have my answer key wrong. Let me just double check. I have to be right here. So, okay. Yeah, this is right. This is totally right. So I'm not just checking my answer, I'm also checking my answer key. Now for this, if you take the square roots to both sides, you will have x in the square root, so we are not going to do that. Instead, we are going to expand this. Open this, 3x squared, we get 9x squared, and then we do plus 2 times this and that, so that's 6x, and then plus 1 squared, which is 1. And then that's equal to 9x. Now, minus 9x to both sides. Here we have 9x squared minus 3x plus 1 is equal to 0. Let's use the quadratic formula. X is equal to negative, here is negative 3, plus or minus square root, and then we have negative 3 squared plus minus, I make so many mistakes this time, I don't know why. B squared minus 4, A is 9, C is 1, and then over 2 times A. So that's 3 plus or minus. This is positive 9 minus, that's 36, so that's negative 27. Imaginary answer. What? It's 9. Okay, I think something wrong with my answer key again. I think maybe I was doing like another question, but I just right there. Yeah, this is totally wrong for my answer key, so let me just double check. Okay, I don't think anything wrong right here, it's just my answer key is wrong. So this inside, we get negative 27 and then over 18. Yeah, so here's the deal. When we have the negative, you are going to use the I. So this right here is 3 plus or minus, here we have the I. But square root of 27, we can break this down as square root of 9 times square root of 3. And this right here is just a regular 3, so I'll put it here. And then this right here stays. And then over 18. Then I'm going to just factor out the 3. So here we will have the 3 plus, 3, and then here we have the 1 plus or minus I square root of 3, and then we can reduce this 1 and this will be 6. Okay, so we're going to read this for the answer. 1 plus or minus I square root of 3 over 6, and this is the answer. Okay, this is the answer. Okay. All right, number 63. It's just a linear inequality. We have 4, 3, 2, 1, 0. 4 minus 3 times x plus 2, and then it's greater than x plus 1, 0. 4, 3, 2, 1, 0. Okay, distribute. So 4 minus 3x, and then that's minus 6. It's greater than x plus 10. I'm going to minus x to both sides, so they cancel. And then I'm going to just... Okay, I'm going to follow what I say. I'm going to combine terms on the one side. Okay, so let me do it again. Okay, number 43. Okay, number 63. We have 4 minus 3 times x plus 2 is greater than x plus 1, 0. 4, 3, 2, 1, 0. It's just a regular linear inequality. Do the usual way. Distribute. So that's 4 and then minus 3x and then minus 6. That's greater than x plus 10. I'm going to combine this and that first. So that's negative 3x and then minus 2. Okay, and then I'm going to minus x to both sides, so they cancel, and then plus 2 to both sides, so this and that cancel, and I will get negative 4x. And negative 4x is greater than 12. Now we are going to divide both sides by negative 4, so they cancel. X is equal to negative 3. No, it's not equal to. It's not greater than either. The answer is what? Less than, right? Less than, right? Less than. And then for inequalities, I'm just going to okay. I am tired. I wrote down the question wrong. It's meant to be x minus 2, so I'm going to do it one more time. Okay, number 63, we have 4 minus 3 times x minus 2 is greater than x plus 10. So 4, 3, 2, 1, 0. It's just a regular linear inequality. So let's go ahead and distribute it. So we have 4, and then that's minus 3x, and then minus becomes plus, and then 6, and that's greater than x plus 10. Combine this and that. Negative 3x plus 10 is greater than x plus 10. And then I'm going to minus x to both sides, so they cancel, and then minus 10 here, so this and that cancel, and of course do the same thing here. Now, this right here gives us negative 4x. It's greater than 0. 10 minus 10, 0. And then right here, we can divide both sides by negative 4. Cancel. But be careful. X, we divide both sides by negative. So we will have to switch the inequality. And then 0 divided by negative 4 is legitimate. It's just 0. So x is less than 0. As an interval notation, we go from negative infinity to 0. So that will be it. Right, that will be it. Okay, I cannot do number 64. What's that amount of space? Okay, we have 2 cosine square x minus 7 cosine x plus 3 is equal to 0. Should we use any of the Pythagorean identity? No, because this right here is actually a quadratic equation, but in terms of cosine x. We can do this. Check this out. We can once again factor it. We need 2 cosine x times cosine x to get that, and then to get positive 3, we can use negative 1, negative 3. Putting the negative 3 here and negative 1 here, because this times this gives us negative 6 cosine x, and this times that gives us negative cosine x. together we do end up with negative 7 cosine x. Nice. So this factors to 2 cosine x minus 1 times cosine x minus 3 to be 0. If you look at this part, then we need cosine x to be positive 1/2. And we can totally take care of that. But for this, we will need cosine x to be 3. Is that possible? No, because this right here, cosine, the smallest value is negative 1 and then the biggest value is positive 1. It's not possible to be 3. In the real world, it does have complex solutions, but we are not going to talk about that. This right here is no real solutions. Okay, so I'm not going to worry about it. Right here, we can do the reference triangle method. So here, cosine is the x value over r. So let's draw a picture real quick. 1, so x is 1 right here, and r is 2, so it's like that. I think we did this like not long ago, I don't remember, but anyways. This right here is 60 degrees of pi over 3, and that's the answer for that picture. And the other one, so I'm just going to get rid of this, right? So I'm not considering that anymore. But the other picture is this. Still 1, okay? But 2 is like this. So this right here is pi over 3, but we go from here all the way to here. So that would be 2 pi minus pi over 3. So we need 3, so that's 6 pi. 6 pi minus that is 5 pi over 3. So x equals our first answer, pi over 3. But they don't line up a straight line. So once you write that down, just go ahead and add 2 and pi. And then for this one, we started right here, 5 pi over 3. And then we add 2 and pi. And we're done. Okay, number 65. Another big equation, so I have to erase this. (2x over x minus 2 minus x minus 2 over x minus 1. Do not cancel the x minus 2. It's a subtraction here. And then equals 5x minus 6 over x squared minus 3x plus 2. Okay, we have a rational equation. Pretty nice. Multiply everybody by its lowest common denominator, right? We have x minus 2, x minus 1. But what's this? In fact, if you factor it, you get x minus 1, x minus 2 as well. So we can just multiply the entire equation by x minus 1, x minus 2. Take this times that, the x minus 2 cancel. Start with 2x, but we need the x minus 1. Take this times that, the x minus 1 cancel. We maintain the minus. Put this in a parentheses though, because there's always invisible parentheses on the top. We will have to take this, multiply by x minus 2. Take this times that, they cancel, so it's just 5x minus 6. Now, multiply this out. We get 2x squared minus 2x, and then right here, we get x squared minus 2x minus 2x is minus 4x, and then plus 4, right? But there's a minus in front, right here. So it's minus x squared plus 4x minus 4, and that's equal to 5x minus 6. Okay, and then perhaps let's combine like terms real quick here. This and that is x squared, and then this and that plus 2x minus 4 is equal to 5x minus 6. Now, minus 5x to both sides. 2x minus 5x is minus 3x. Minus 4, add the 6. Minus 4 plus 6 is plus 2. It's equal to 0. Factor it. From here, x it looks like it's 1. From here, x looks like it's 2. Nope. Nope. Because right here, remember, x cannot be 2. From here, x cannot be 1. We are totally violating the domain. So, in fact, this equation, after all the hard work, no solution. No solution. Ooh. Okay, number 66. Square root of 4x plus 1 equals plus square root of 3x minus 2 equals 1. Now I'm just going to do it the usual way. Move this to the other side. So we get that by itself, then square both sides. That way they cancel, so that's 4x plus 1. Now, expand this, take this, square that, it's 1, it's a minus, so put that down. We take 2 times this and that, so it's 2 square root of 3x minus 2. And then lastly, we add this term square, which is just inside, 3x minus 2. Okay. Now I'm going to just minus 3x here, minus 3x here. And then I'm also going to just minus 1, minus 2. Sorry, minus 1 plus 2. So minus 1 plus 2. So this and that cancel. That's a minus 1. Plus 2 right here. So they cancel. So this right here is x. 1 minus 1 is 0 and then plus 2. So it's plus 2. That's equal to negative 2 square root of 3x minus 2. Now, you can divide both sides by negative 2, but you'll get fractions, so maybe not. And in fact, you cannot just say, hey, we have a negative, we get no solution. Not really, because x, we don't know what it is. It could be negative. Negative divided by negative is positive. So anyways, let's just square both sides. So this is x squared plus 2 times this and that, which is 4x, and then plus square of that. Now, negative 2 squared is 4. Square root cancel. We just get inside. So that's 3x minus 2. Okay? So, distribute that real quick. This is x squared plus 4x plus 4. That's 12x minus 8. Okay, I'm going to move the 12x to here. So 4x minus 12x is minus 8x. 4 plus 8 is plus 12, and that's equal to 0. So far, so good. And then we get x minus 2, x minus 6 for the factors. And right here, it looks like we have x is equal to 2, x is equal to 6. How wonderful. Because both of them are positive. So both of them should work, right? No, I cannot promise anything because we are solving a square root equation. After squaring both sides, we cannot say anything unless we check. So check when x is equal to 2. So this is just a check. Plugging 2 into all the x's, square root of 4 times 2 plus 1 plus square root of 3 times 2 minus 2. Are we going to get 1? This is 9, so that's square root of 9 plus this is 6 minus 2 is 4. I don't think so. Of course it's not equal to 1. So in fact, oh, that means 6 is right, yeah? No. Double check. Check. if x is equal to 6. Plugging 6 into all the x's, so we have square root of 4 times 6 plus 1, and then plus square root of 3 times 6, and then minus 2. Are we going to get 1? 24 plus 1 is 25, plus 18 minus 2 is 16. That's 5 plus 4, definitely not equal to 1. You can never trust a square root equation. No solution. No solution for this equation. Okay, wow. We are about 2/3 done. Okay, number 67. It's like a weird exponential equation because we have 54 over 1 plus 3 to the negative x is equal to 2. And you bet 1, 2, 3, 4, 5. Anyways, it's a rational equation even though the x is in the exponent. We can still multiply this to both sides. So we get 54 is equal to 2 times 1 plus 3 raised to the negative x power. Right here, I'm actually not going to distribute because it will be easier if we divide both sides by 2. Because that's divisible by 2. And we get 27. And we just get this, 1 plus 3 to the negative x. Minus 1 to both sides, so that means 3 to the negative x is equal to 26. Now, how do we get rid of the base 3? Well, we use logarithm. Take log base 3 to both sides. Cancel, cancel, we get negative x equals log base 3 of 26. And this is an irrational number, so just leave the answer like this. Then divide the negative 1 to both sides. So ladies and gentlemen, negative log base 3 of 26. Done. Okay, number 68. It's a quadratic equation. Here we have x to the 4th power minus 8. X squared plus 8 is equal to 0. You can try to break down 8 is at 2 times 4, but we're trying to get negative 8. Negative 2, negative 4, they don't work either, so either quadratic formula or completing a square. Here, I'm going to complete the square because we have a 1 right here already, and this is an even number. But wait, this is x squared and x to the 4th power. Can we still complete the square? Yes, you just have to keep this x squared term. So let me show you. Move this to the other side, x to the 4th power minus 8 x squared, and move that, we get negative 8. Now, we are going to add the magic number. To figure that out, we take 1/2, and be sure you have a 1 in front of the leading coefficient. We take 1/2 of this coefficient, and then square that. So that's negative 4 square, which is 16. That's a magic number we are going to add to both sides. And this is so magical because the left-hand side will become a perfect square. If you factor it by the tic-tac-toe, you will get x squared minus 4. Yeah, x squared minus 4, what am I talking about? Yeah. Yes, x squared minus 4. And then the right hand side, this is equal to 8. Okay, this is equal to 8. Now, I'm going to take the square roots to both sides, plus or minus, so they cancel. Have a look though. Square root of 8, we can break it down. This right here is the same as square root of 4 times square root of 2. And this becomes a regular 2. And then we have the square root of 2. and then we still have the plus or minus in the front. And then here we have x squared minus 4 equals this. This is weird. I'm going to move the 4 to the other side. So x squared equals 4 plus or minus 2 square root of 2. Furthermore, I'm going to take the square roots to both sides, so that this and that cancel, and then put a plus or minus. So all in all, x is equal to plus or minus square root of 4 plus or minus 2 square root of 2. Yes, we have this right here for the answers. So how many answers do we have? So in fact, we have 4 answers. I don't recommend you guys to write this down as the notation because it's a little bit bizarre, but I think it's understandable. But I will tell you though, the 4 answers are, you take the positive and positive. So you first get square root of 4 plus 2 square root of 2. And then the next one is you take the positive and the negative. So positive square root of 4 minus 2 square root of 2. Then next you take the negative and the plus. So it's negative square root of 4 plus 2 square root of 2. And then finally, you take both negatives. So negative square root of 4 minus 2 square root of 2. Yeah, so that will do it. Number 69 and number 70. I'm going to do them at the same time. X cubed equals 64x. And then right here, number 70. Just x cubed equals 64. Remember, if we have a polynomial equation, we're going to find out all the solutions, including the complex solutions, the non-real ones. Have a look right here. The only difference is the x. I'll tell you, this right here, it's slightly easier. Move this to the other side. Do not divide both sides by x, otherwise you will miss out 0 for the answer. Because right here, you factor out the x first. Right? And then this is a difference of 2 squares. So this right here is x times x minus 8. X plus 8 is equal to 0. From here, you see x is 0. From here, it's 8. From here, it's negative 8. So we have 3 answers, and they are all real. For this, move the 64 to the other side. So we get x to the third power minus 64 is equal to 0. But it has no x. What do we do? Well, this is actually the difference of 2 cubes. X to the third power minus 4 to the third power. Well, we have to remember how to factor the difference of 2 cubes. We get x minus 4 times x squared. I'll put a square like this. And then plus. If it's a minus, the first one is minus, and the next one is plus. And you do this times that, which is 4x. And then you add this square, which is 4 squared. That's 16. It's equal to 0. Now, from here, you can see x minus 4 is equal to 0, gives you x is equal to 4. From here, you'll just use the quadratic formula. X squared plus 4x plus 16 is equal to 0. I'm going to complete the square because this is 1, this is even, and this is a whole number. Move this to the other side. And then I'm going to add a magic number, which is 1/2 times this coefficient, and then square. Inside is 2. Square that, we get 4. So this is plus 4, and then also plus 4. Factor it, we get x plus 2 squared, and that's equal to negative 12. Take the square roots to both sides. Don't forget the plus or minus. Cancel. Now, x is equal to, I'm going to put a 2 to the other side, so that's a negative 2. And then we have the plus or minus. Here we have a negative in the square root, so we better have the I. And then square root of 12. This is the same as, well, we can do square root of 4 times square root of 3. And this is just a regular 2. So I will put regular 2 right here, and then the square root of 3 right here. So just like that. Only one answer is real, and then the other two answers, both plus or minus, they are complex or they are non-real. Done with this page. Alright, so just like one more page to go. Okay, 30 questions. I can do it. You can do it too. If you're still watching, if you have been watching, maybe not just watching, if you have been doing, right, that's even more important, right? Because of course it's easy to see me do the math. The most important thing is that if you can do the math, not me, right? 71. 3 cosecant square x minus 4 is equal to 0. Let's just go ahead and get into it. Write this as over sine square. So I'm going to write this as 3 over sine square x. Put a 4 to the other side, yeah? So like this. And then multiply this to both sides, divide the 4 to both sides. So I will get sine square x equals 3 over 4. Agree? That down here. Then take the square roots to both sides. So sine x, here we have like many situations. Sine x equals, let's take the positive version first. Positive square root of 3 over square root of 4, which is 2. And the other one is sine x equals negative square root of 3 over 2. Right here, we have to have 2 reference triangle. Right here, we have to have 2 more reference triangle. I know it's a lot of work, but we can do it. Okay, here. T is y over r. So I'm going to draw 2 pictures right here. So here we have square root of 3 and then 2. So this first angle is pi over 3. Right? And in the meantime, I'm actually going to draw the other triangle, just to save some space. The other triangle, it's going to be right here. In fact, it's just a reflection about the y-axis, and it's 2. So this is also pi over 3, but if you go from here to here, that's pi, the blue one is pi minus pi over 3. So get the common denominator, that's 2 pi over 3. So we have this one and we have that one. Now for this, it's actually just the below version. So right here, I'm actually going to draw it like this. Still y over r. First, you can have the triangle down here. Let me match the color. So negative square root of 3 and then 2. And then this is still pi over 3. But if you go, actually, let's do the other one first. Okay. Square root of 3 down here, and then that's too long. Alright, so if you go all the way from here to here, the red angle will be pi plus pi over 3, which is 4 pi over 3. Right, get the common denominator. And then the other version is right here. So it will be from here to here, that's pi over 3 that you're missing from 2 pi. So I will do 2 pi minus pi over 3. So let's get a common denominator. That's 6 pi. So that's 5 pi over 3. So we have these 4 answers. This one, this one, this one, and this one. But if you take a closer look, you will see that this one and that one, they form a straight line, yeah? Likewise, this one and that one, they also form a straight line. So, how did I write my answer key? So, I'm just going to start with this, and then just add that, so this and that together. Check this out. X is equal to, I'm just going to put them in red, pi over 3, this one and this one. We can just add pi to it, get to here, right? So just add n pi. So you're not writing 4 separate expressions, because starting from here, once you add pi, you get to here, which is 4 pi over 3, and you're done for that. And then we can also do the same right here, which is that blue angle, 2 pi over 3. If you add pi, you get to here, so just plus n pi. So you can just write your answers with these 2 expressions, right? All right, number 72, I should be able to fit in here. Double absolute value equation, 3x minus 2 equals absolute value of 5x minus 14. All right, for this one, I'm going to first take out the absolute value. So that's case 1. Just take out the absolute value. So 3x minus 2 equals 5x minus 14. And then the second case is you take out the absolute value and negate one of them. I know this is plus or minus, but in fact you can just, if both are negative, that's the same as case 1, so you don't have to do that. If this is negative, that's positive. Seriously, you can just negate one of them. So when you have a double absolute value equation like this, absolute value equation on both sides, you just need to do 2 cases. Case 1 and then case 2. Take that out, and then take out the absolute value but negate the result right here. Okay, so right here I'm just going to move this to here, so I get negative 2x. Move this to here, that's equal to negative 12. Yes, and divide 2 to both sides, x is equal to positive 6. And when you have a double absolute value equation like this, I will tell you this will be the answer. You don't have to check. Just trust me. Well, if you do it, you should check. Plugging, it works. I did that in my head. Anyways, right here, 3x minus 2 equals negative 5x plus 14. So that's 8x equals 16. So x is equal to 2. So 2 answers, 6 and 2. Right, number 73. X minus 3 over x squared minus 3x plus 2. And then plus 2 over x minus 2. And that's equal to 2. Rational equation. Factor this real quick. X minus 1, x minus 2. We have the x minus 2 in common already, so we just need to multiply by x minus 1 and x minus 2. Take this, multiply with that, they cancel. Start with x minus 3 plus 2. This and that will cancel, but we need the x minus 1. Equals 2 times all that. Okay, and then distribute and fix all the stuff. So x minus 3 plus 2x minus 2. Here, this is x squared minus 2 minus 1, so it's minus 3x, and then it's just that actually. And then we have the 2 in front, so that will give us 2x squared minus 6x, and then plus 4. Okay, so I'm going to combine items here and then move the things to the other side. So that's going to be 3x and then minus 5. So I'm going to minus 3x to both sides right here, and then plus 5, okay? So that will give us 0 here, and then 2x squared minus 9x plus 9. Okay, is this factorable? Yes, it's actually factorable. Let's try it. Alright, 2x and x minus 3, it does work. So that's negative 6x, that's negative 3x. So together, we do get negative 9x. So 2x minus 3 times x minus 3 is equal to 0. Right here, x equals, put the 3 to the other side, divided by 2. Here, put the 3 to the other side, so 3. They both work because the restrictions are what? X cannot be 1 and x cannot be 2. But we don't have that, so they both work. Okay, number 74. X to the 2/3 power and then minus 5x to the 1/3 power. Wow, what is this? Don't worry, it's also a quadratic equation in terms of this x to the 1/3 power. Let's do the tic-tac-toe and you'll see. I need x to the 1/3 and x to the 1/3. Yeah, and then to get past the 6, let's do negative 2 and negative 3. Does it work? Yes. That's negative 3x to the 1/3, and this is negative 2x to the 1/3. Together, we do end up with negative 5x to the 1/3. So that means x to the 1/3 minus 2 times x to the 1/3 minus 3 is equal to 0. So that means this term, x to the 1/3, is equal to 2. And then this term, x to the 1/3, is equal to 3. Now, how do we get rid of the 1/3 power? Just cube both sides. Because you multiply the powers. 1/3 times 3, they're gone, right? X equals 2 times 2 times 2 is 8. And then for this, raise that to the 3rd power. X equal to 3 to the 3rd power is 27. If you plug in and check, they work. Especially for 1/3 power, it's actually like the cube root. It's actually okay. Now for number 75, I will see if I can fit in here. Square root of 4x plus 5 equals square root of x plus 2. So square root equations again. Square both sides. So this is 4x plus 5. Okay, square this is just x plus 2 times this and that. 2 times 2 is 4, and then the square root of x. Lastly, this thing square, which is 4. Now, I'm going to just minus x to both sides, and then minus 4 to both sides. Okay, to make it clear, here we have 3x plus 1 equals 4 square root of x. Do not divide the 4, otherwise you get fractions. So let's just square both sides. Open this. 3x squared is 9x squared plus 2 times this and that, which is 6x, and then plus this square, which is 1. 4 squared is 16, and the square root of x squared is just x. Now move this to the other side. So minus 16x. So that's 9x squared minus 10x plus 1 is equal to 0. We can actually factor this pretty nicely. 9x minus 1, x minus 1 is equal to 0. From here though, x is equal to 1 over 9. From here, x is equal to 1. Let's plug in, check. Plugging 1, this is square root of 9. Plugging 1 here, that's square root of 1 plus 2. Let's check. Plugging 1 over 9, that's a little bit tougher. 4, 1 over 9 plus 5. It works. I did that in my head. No, just kidding. I did that beforehand. The answer key says they both work, but you should check it out. Alright, I'm going to retire this marker after 75 questions. So don't worry though, I have another one right here ready. So a fresh one. And then you guys can take a look at my this thing, and I'm going to use the inside now. How are you guys doing? Are you guys still watching? Are you guys still doing it? Or do you guys just watch the beginning for like 30 seconds and then watch the end for like another 30 seconds? Number 76. Log equation. Log of base 4 inside is 3 over x plus 15. Take a guess, what am I going to make that equal to? 1, 3, 4, 5. Of course 2, right? But let's make it slightly more interesting. Negative 2. It's okay for the output of a logarithm to be a negative number, but not the inside. So this is okay. Now, still do the same thing. Take 4 to that power, 4 to that power, so they cancel. So the left hand side is 3 over x plus 15. And then 4 to the negative 2 is just 1 over 16. 4 to the negative 2 is the same as 1 over 4 squared. That's why it's 1 over 16. Now we can just kind of cross multiply or multiply both sides by the common denominator, same idea. So I'm just going to cross multiply, same thing. So 3 times 16 equals 1 times that, which is just x plus 15. That's 48 equals x plus 15 minus 15, so x is equal to 33. Plugging real quick, 33 inside, it does work. The inside is positive, so this right here checks. 77. Absolute value inequality. 2x minus 5 less than or equal to 13. So we did one of this already. Now you have to remember, if the less than or less than equal to case, what do we do? Remember, think about distance. You cannot go out too much, so it's in between. So this right here, 2x minus 5, is in between of negative 13 and positive 13. Okay, and let's do it. Add the 5, add the 5, add the 5. So that's negative 8. And then divide 2, 2, 2. So negative 4, 9. So just like this. Okay, interval notation, negative 4, 9. Okay, system of equations, but with fractions. So for this right here, we have 9x minus 2y is equal to 15. And then the second equation is 3x plus 5y equals 27 over 2. What do we do? Of course, we're going to get rid of the y. Why? Don't ask. Just do it. You can get rid of the x. In fact, let's get rid of the x this time. Yeah, let's get rid of the x this time. Why? Because 3 and 9, the least common multiple of them is just 9. We have the 9 right here already. So it will be easier if we multiply the second equation by -3. Even though we have a fraction here though, it's okay. Let's just deal with fractions. So this equation stays, but then take this times that is -9x, this times this is -15y, this times this, just multiply the top, so that's -18(1) over 2. Combine them, they cancel. This and that is -17y, and 15 it's the same as get a common denominator, which is 2, so 30 over 2. Combine the top is -51, yes, over 2. Now I'm going to multiply both sides by 1 over -17, so this is the multiplication. So that this and that cancel, we get this is a multiplication, and this is a multiplication. So I just do like this. Okay, and then this is y equals. We can actually reduce this. First, get rid of the negative. 17 goes into 17 one time. 17 goes into 51 3 times. So the answer is nicely 3 over 2. And then if we put this maybe into the first one, because that has a 2. Put that there. 9x minus 2 times 3 over 2 is equal to 15. They cancel, so 9x minus 3 is equal to 15. 9x is equal to 18. X is equal to 2. Okay, just like that. Why is it only 79? I thought it was at 89 already. No. Okay, x over 2x plus 3 minus it's equal to 1. Okay. So right here, the denominators are different and cannot factor this. So we multiply the entire equation by both of them. Have a look. When we take this times that, the 2x plus 3 cancel. We have the x, but we need to multiply it with the x. Oh, sorry, plus 4 right here. Plus 4. Continue, minus, remember invisible parentheses, so write that down. The x plus 4 will cancel. So with this, and then finally 1 times this is just that. So 2x plus 3, x plus 4. Alright, and then do usual business. So this is x squared plus 4x, and then, okay, I'm going to do this minus, and then inside is 2x squared, and then x times 3 is 3x, plus 6x is plus 9x, and then plus 9. That's equal to 2x squared. 2x times 4 is 8x, plus 3x is plus 11x, and then lastly plus 12. Okay? And then I'm going to distribute the negative right here. So minus 2x squared minus 9x minus 9 equals 2x squared plus 11x plus 12. Okay, let's see what can we do. Let's just combine terms on the left hand side first. So this and that. That's negative x squared, and then this and that is minus 5x, and then that's minus 9. Okay, and then I would like to move this to the other side. Let's see if we can do this in our head. It should be. So we just add the x squared here, so that will give us 3x squared. And then add a 5x here, so 11 plus 5 is 16. And then 12 plus 9 is 31. No, 12 plus 9 is 21. Whew. So that is equal to 0. Now, how do we factor this though? Okay, 3x and x. 7 and 5. Too big. Oh, 3 and 7. 3 here. What did I say? 7 and 5. 3 and 7. 3 and 7. This times this is 9x. This times this is 7x. So together we do get a 16x. Checks. So we have 3x plus 7 times x plus 3 equal to 0. From here, x equals negative 7 over 3. From here, x is equal to negative 3. Right here, x cannot be 2/3. So we are good. X cannot be negative 4. So we are good. Both of them are legit. Right, number 80. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, exponential function. Get rid of this number first. Divide both sides by 12. So cancel. Let me just do this to make it really clear. So this is 3 raised to the 4x minus 5 equals, that's just 1/2. Now, get rid of the base 3, right? We use log base 3. So this and that cancel. So we get 4x minus 5 equals, you can write it like this. I'm just going to keep it for now, and later I'll show you guys another form for the answer. And then the rest is just add a 5 to both sides. And then divide the 4 to both sides. So 5 plus log base 3 of 1/2 over 4. So you can do it like that, no problem on this. And here's the thing. This is 1/2. We can write it as 2 to the negative 1 power. So I'm going to just show you. This right here is 5 plus log of base 3 of 2 to the negative 1 power and then over 4. And what we can do is we can put the negative 1, the power, to the front. So this right here will really become 5 minus log base 3 of 2 over 4. So this right here is how I have it on my answer key, right? Usually you don't want to have like a fraction instead of a big fraction, so that's the deal. Now number 81, another square root equation. So 2x plus 1 equals square root of 10x plus 5. Do it. Square both sides. Open it. 4x squared plus 2 times this and that, so it's 4x plus 1. That's 10x plus 5. Okay, 4x squared stays. 4x minus 10x minus 6x. 1 minus 5 is minus 4. That's equal to 0. Let's divide everybody by 2. So 2x squared minus 3x minus 2 is equal to 0. I hope we can factor this. 2x and x negative 2 here and 1, it does work. That's negative 4x, and that's positive x. So we do get negative 3x. So this means we have 2x plus 1 times x minus 2 is equal to 0. So from here, x is equal to negative 1/2, and then x is equal to 2 right here. Now, they both work. They both work, they do. Right, they do. If you plug in negative 1/2, 2 times negative 1/2, even with negative number it works, because here, it's really you get 0. And then on the right hand side, 10 times negative 1/2 plus 5. That's actually negative 5 plus 5. You also get 0, so this right here works. If you plug in 2, you have 2 times 2 plus 1, which is 5. If you plug in 2 in here, square root of 10 times 2 plus 5, that's square root of 25. Of course, it's equal to 5, so it also works. So this time, both of them work. So be really careful whenever you have a square root equation. You really have like all three possibilities, right? Maybe just one answer, or maybe no answer, or maybe more than one answers. Okay, number 82. We are dealing cubic inequality. Like again, no, actually no. It's a, what's that called? Exponential function. 2, 3x plus 1 equals 5x plus 2. So, we did a similar question before. When the bases are different and then it's not easy to make them the same, then we'll do the following. I'm going to fix that. Break it apart. This is 2 to the 3x times 2 to the first. On the right hand side, this is 5 to the x times 5 to the second. This right here is just, and furthermore we can do the following. Check this out. This, it's the same as saying 2 to the third power first and then raised to the x power. Because when we have this, we can multiply the exponents. So 3x can be written like that in the exponent form. 2 to the first is just 2, and then this is 5x. 5 to the second power is just 25. Okay? This right here is just 8. Now, I'm going to put all the terms with x together and then all the numbers together on one side. I'm going to bring that to the other side. So divide both sides by 5 to the x. So this and that cancel. And then divide both sides by 2. So this and that cancel. And right here, we can write it as 8 over 5 raised to the x. And that is equal to 25 over 2. Then we take log base of 8 over 5 to both sides. This and that cancel, and then we can get the x by itself, which is log base of 8 over 5 and then 25 over 2. I'm just going to leave this for the answer. It's really compact. You can expand it, but there's absolutely no need. This is good. I can give you guys the approximation for this. Is 5.374. 5.374 if you use a calculator. Because sometimes when you do this, maybe the direction says, hey, use a calculator to figure out the answer. So make sure you know how to do that as well. Next, number 83. Cubic inequality. X cubed plus 5x squared minus 9x minus 45 is greater than 0. Let's just do it. Factor by grouping. First two terms, factor out the x squared, and then we get x plus 5. And then here we have a minus, bring that down. So factor out a 9 we get x plus 5. Okay, so that's x plus 5, and then x squared minus 9, and then this right here is x plus 5, and this is x minus 3, x plus 3. Now, what do we care? From here we care about negative 5. From here we care about 3. From here we care about negative 3. Draw a number line. Negative 5, smallest, next is negative 3, and then lastly is 3. It's just greater than, so they are all open. And once again, everything is to the first power. So, pick a number less than negative 5. Let's say we have negative 6. If you plug in here, that's negative times negative and times negative. So they are all negative. We don't want that. So that means if you check this right here real quick, you take this, don't want that, you take that. So x is in between of negative 5 and negative 3, or x is greater than 3. So negative 5 comma negative 3 union 3 to infinity. Just like that. All right, number 84. This is a very, very fun one. Ready? 2 over, here we have x squared plus 3x and then minus 4. And then we want this to be equal to 0. Notice there's no x on the top. So what do we do? And this is an equation. Here, if you multiply this to both sides, 0 times that is just 0, so it's 2 is equal to 0. In fact, if you have this equation, right away you can just say no solution. Because if you do multiply this to both sides, you just get 2 is equal to 0, which doesn't make sense, right? So that's it. There's no x. In fact, the only way for a fraction to be 0 is that you have to make sure the top is equal to 0, but it's just 2. It's not possible to be 0. So no solution for that. Okay, number 85, I'm going to do it here. Tangent of 2x, it's equal to square root of 3. I'll show you guys how to do this fast. Square root of 3, it's the same as square root of 3 over 1. And I'm just going to look at y and x like so. And then use the triangle method. So y is square root of 3, x is 1. So we have our special right triangle that's 60 degrees, which is pi over 3. And then the next one is going to be here for sure, right? So all you have to do, and here, all you have to do is just figure out the first angle, and then the rest is just add pi and pi to it. But here we have 2x, so we want to have 2x. It's equal to, starting right here, pi over 3, but we add n pi. Okay? And then just multiply everybody by 1/2. X equals pi over 6 plus n pi over 2. Just like that. Okay, 86. We have 500. No, 5,000 over. This is like the application of like exponential function equation. E to the negative 0.02x equals 4,300. 1, 2, 3, 4, 5, also the 0. So what do we do? multiply this here, divide that here, so have a look. It becomes 5,000 over 4,300 equals this, 1 plus e to the negative 0.02x. Okay? Now, I will show you guys how we can like solve this kind of equation like fast. I'm going to tell you like x is equal to what, right? Follow along. This is our input. I'm not going to reduce that because usually for this kind of equations, you use a calculator to get the approximation, okay? X, 5,000 over that, let's write that down. First, we will have to get rid of the 1, so we are going to minus 1. So that's usually put a minus 1 here, yeah? Next, we have to get rid of the e. To do so, we take the ln of both of these things. So ln of this thing. So we got rid of the e. Then we have to get rid of this. Well, we divide, right? So it's 1 over negative 0.02. That's it. And then if you use a calculator, this right here is approximately 90.76. Okay, just like that. Okay, number 87, almost done. Am I tired? You don't know. Are you tired? You let me know. All right, number 87. This right here is just a scary looking power equation. So x minus 1 and I have 2/3 for you. And let's say this is equal to 25. Okay, why don't you take a minute? You should have tried these questions before you watch the videos. But I'll tell you, this right here actually has 2 answers. Ready? Let's do it this way, just to be safe. Okay, let's take a look like this. I think it will be much more clear. So if you take a look right here, this is x minus 1. The third power, the 1/3, this denominator, it's like saying, let me just make it super clear for you guys. This right here, it's like saying we have the cube root of whatever that is. And then after that, we square that, and that's equal to 25. And now, do you guys see why this has 2 answers? Because to get rid of this square root, to get rid of this square, we will have to take the square root to both sides, and then plus or minus. So we get the cube root of x minus 1 equals either 5. Let me just separate it to make it clear. Cube root of x minus 1 is equal to 5. Or the other case is the cube root of x minus 1 is equal to negative 5. And then raise both sides to the third power to get rid of this. So x minus 1 equals 125, that's 5 cubed, plus 1 to both sides, 126. Here, same thing. Cube, cube. X minus 1 equals negative 125. Add 1 to both sides, x is equal to negative 124. 2 answers, and they are both legit. You can plug in and double check. When you have the negative, because we have the square on the outside here, the output will still be positive. So that is good, and that is good. Now, number 88, let's solve this inequality. X plus 1 is less than or equal to 3x minus 2. is less than 4. Here is the deal. This time, not only we have the x in the middle, but also here. So be careful with this. I will recommend you guys to break this down into 2 parts. So part 1, or case 1, is you look at x plus 1 less than or equal to 3x minus 2. And then you also have to satisfy this situation. Let's do this first. Right here, you can minus x to both sides. I think it's easier this way. Cancel. So that means I should add 2 to both sides. So that's 3. And then that's 2x. Divide 2 to both sides, so 3 over 2 is less than or equal to x, or x is greater than or equal to 3 over 2. Now, case 2, condition number 2, you should put 3x minus 2 less than 4. Then here, just do the usual business, add 2 to both sides, 3x is less than 6, and divided by 3 to both sides, so x is less than 2. Now combine case 1 and 2, right? So as you can see, x, it's in between of this and that, so you just write it down like this. X is in between of 3 over 2 and less than 2. And then as an interval notation, 3 over 2 comma 2, but not including the 2. Just like that. Okay. All right, number 89. Let me actually do a nonlinear inequality, but this time the power actually has like even powers. So I'm going to factor for you guys. Actually, no, I'm not going to factor for you guys. I'm going to do this right here. Just take a look real quick. Let's say we have x cubed. And then, let's do this. Minus 6x squared and then plus 9x. Let's say this is less than or equal to 0. We can factor it. Factor out x first. Furthermore, this can be factored in. And this time now we get x times x minus 3 squared. Be careful. This time we care about 0, right? X is 0. And we also care about 3. But the signs, they do not alternate. Have a look. Here is 0, here is 3. We do want to include them because we have the equal sign here. Now, pick a number less than 0. Let's say negative 1. If you put negative 1 here, that's negative. But if you put negative 1 here, negative 1 minus 3 to a second power is positive. So this right here, it's actually negative, but we want that. So we take this portion. Okay, we want that portion. Now, if it's like, okay, I don't want to make this like more confusing than it has to be. I think it's easiest if you just like do it the safe way. Pick another number in here. Let's say 1. If you put the 1 here, you get positive. If you put 1 in here, 1 minus 3 is negative 2. And then if you square that, is positive. But you don't want that. You don't want that. You don't want that. Because we are trying to look for a negative 1. Then the negative number. Now pick a number greater than 4. Pick a number greater than 3. So let's say 4. If you put it here, first it's positive. If you put it here, it's positive. So this right here, again, you do not want to include. Okay, so what does this do though? This right here is that we can have x is less than or equal to 0, okay? X is less than or equal to 0, x is less than or equal to 0, or we also take 3, because if x is exactly 3, you get 0, which is 0 is less than or equal to 0. Let me just think about the graph of this thing. Oh yeah, so this or x is equal to 3. Okay. Now, I have a little... I don't remember how to write the interval notation if it's just a point. So I'm going to box it here. Because this right here, the interval notation is negative infinity to 0. Good. But, okay, interval notation is a set. So I'm going to think about this like union. For this right here, it's just a set of the number 3. I think this right here might work. It's kind of strange because usually you have like actual intervals. But my point is, if you have some even power or like, if you have some even powers, be really careful. They don't alternate anymore, right? Be really careful with that. So, that's that. Almost done. Okay. Square root of 2 raised to the 3x plus 6 equals 8 raised to the x minus 5. Exponential equations, and in fact we can actually make the base the same. 2, the square root is the same as 1/2 power, and then we have the 3x plus 6. And then for the 8, oh my goodness, I almost forgot about the 8. The 8, we can look at this as 2 to the 3rd power, and then x minus 5. Could you have done this with logarithms? Yes, but this is better. Now multiply the powers. 2, and then this is 1/2. 3x plus 6 equals 2, 3, and then put parentheses around this. And then now you can say this has to be equal to that. Distribute it. Sure, let's distribute, why not? Let me see. I'm just going to write it, check this out. I'm not going to distribute yet. 1/2 3x plus 6 equals 3x plus minus 2. Okay? Why don't I want to distribute? It might be slightly easier if I multiply both sides by 2, because that way I don't have to worry about the fractions. So 3x plus 6 equals, that's 6. 6 times x is 6x. 6 times 5 is 30, but that's a minus. Okay, so I will do 3x minus 6, which is negative 3x, equals, I will take negative 30 minus 6, which is negative 36. Divide negative 3 to both sides, x is equal to positive 12. Last 10 questions. Right, next one, number 91. 1 minus cosine x over 1 plus cosine x, and this, it's equal to 3. Rational equation, multiply this to both sides. So we have 1 minus cosine x equals 3 times 1 plus cosine x, and then distribute the 3. So that's 3 plus 3 cosine x. And let's do this. I'm going to add cosine x to both sides, so they cancel. So I will minus 3 to both sides, So they cancel. Allow me to write this down first. 3 plus 1 is 4, and then we have cosine x. 1 minus 3 is negative 2. And then of course divide both sides by 4. So this time we are looking for cosine x equals negative 1/2. Now, cosine is x over r. So draw the picture real quick. X is negative, so I'm going to just focus on the left hand side. So, negative 1, and then r is 2. So that's 60 degrees, which is pi over 3. So the first answer from here to here is pi minus pi over 3. That's 2 pi over 3. But of course, we can also have the angle down here. So that's also pi over 3. And if we go all the way from here to here, let me just draw like this in blue. The blue one is pi plus pi over 3, which is 4 pi over 3. All right, so starting with 2 pi over 3, we just need to add 2n pi. And then the other piece is starting at 4 pi over 3, and then we add 2n pi. Number 92. Square root of 13 minus x squared minus 2 over square root of 13 minus x squared is equal to 1. So square root and also like fraction looking, but it's okay. Multiply everything by the denominator first. So you can see the fundamental is pretty much the same, just depending on what kind of function you are dealing with, right? So take this times that, they cancel, right? We just have the inside, so we have 13 minus x squared. Next, this and that, they cancel completely, so it's just minus 2. Yeah, this and that cancel completely, but this and that, the square root cancel, that's what I meant. And then, okay, this is equal to 1, so we'll still have this. That's equal to that times 1, so 13 minus x squared. What? Okay, let me check something first. 3. Okay, fine. Okay. This and that, so we have. No, this doesn't work. Oh, sorry, my bad. I thought it was negative 11, otherwise, that's not possible. Anyway, this is negative x. Let's do this, because we have to square both sides later. I'm going to write this as 11 minus x squared, and that's equal to square root of 13 minus x squared. Do I really want to square both sides? x 是3的话9是3。Yeah. Okay, so apparently my question and the answer key should be correct, but I don't know. I didn't do this beforehand. Let's try. If I square this, I square this first, which is 121 minus 2 times this and that. So it's 22x squared. And then plus this square, which is x to the 4th power. That's why I didn't want to do this. But we'll see. This and that cancel. So it's 13 minus x squared. Now, I'm going to add x squared. Okay, this is a quadratic in terms of x squared. That's manageable. Okay. Okay. Writing down x to the 4th power first. This is minus 21x squared. 108. Yes, 108. And then x squared, 108 is 9 and 20, 9 and 12. 9 and, wait. Oh. This and that is positive, so it's 9 and 12. Minus 9 and minus 12. So it will work. So that's negative 21 x squared. So we have x squared minus 9, x squared minus 12 is equal to 0. From here, you can see x is equal to plus or minus 3. From here, you can see x is equal to plus or minus square root of 12. I know I didn't simplify it, but square root of 12 or negative version of it, they don't work. Here, if you put square root of 12 right here, you get, so if you check this right here real quick, okay? Square root of 13 minus, let's just take the square root of 12, square that, and then minus 2 over square root of 13 minus square root of 12, and then square that. That is what? That's 13 minus 12 is just 1, so square root of 1. Minus 2 over square root of 1. That's 1 minus 2. This is negative 1. It's not positive 1. So that, and then if you put negative right here, it still doesn't work. It still doesn't work. But if you put 3 and negative 3, I'll tell you they do work. Right? So both of them work. So plus or minus 3 is the answer. I didn't expect we end up with a quadratic polynomial, and then it's actually doable, so all good. I don't remember what happened. All of a sudden it's like question number 93 already. Like, seriously, it's like when I was running my marathons, it's like I cannot remember the first mile, and then once I get to a mile 13 or mile 15 or mile 20, it's like I don't remember what happened. And then mile 22 is like, oh yeah, I'm almost done. And then mile 26, yeah, it's just really, really nice. And of course, today I have one of my marathon medals I want to show you. All right, number 93. X minus y is equal to 5. And then square root of x minus square root of y is equal to 1. Now, system of equations, but we cannot eliminate it because I cannot just square this. No. So what we have to do is substitution. Right here, let me just add a y to both sides. X is equal to y plus 5, and now I'll put this into this x. So we have square root of y plus 5 minus square root of y is equal to 1. Okay, and in fact this is just one approach to do it. You can also kind of factor this a little bit and then go about it, because I think I've done a lot of this kind of equations already, so why don't I show you guys something else? I think it's fair. Let's do this. Okay, so from x minus y is equal to 5, check this out. I'm going to look at this as square root of x squared minus square root of y squared is equal to 5. Because now we can look at this as a difference of two squares. Factor it, we get square root of x minus square root of y times square root of x plus square root of y. That's equal to 5. Guess what? Don't we know what this is already? Yes, we do. This right here is just equal to 1. So Surprisingly, x minus y is equal to 5. Right? From here, we deduce that square root of x plus square root of y is also equal to 5. Now, what good does this do? Now we can eliminate. Have a look. So, I'm just going to say this is like our equation number 1. This is our equation number 2. And now this is our equation number 3. I'm just going to use 1 and 3. No, use 2 and 3. So 2 is this. Square root of x minus square root of y is equal to 1. And then 3 is square root of x plus square root of y is equal to 5. Isn't this so wonderful? Because the moment we add them, this and that cancel, so we just get 2 square root of x equals 6. Divide 2 to both sides. Square both sides. Aha, x is equal to 9. And then once we know x is equal to 9, we can come here. 9 minus y is equal to 5. So that means y is equal to 4. Done. Alright. Next one, I have a 1 equations from 1 to 9 for you guys again. So this is 1 over 2x plus 3 over 4 x plus 5, and then it's equal to, I don't have enough space. And this equation is very long, so I'm going to 1 over 2x plus 3 over 4 x plus 5 equals 6 plus 7 over 8, and then x minus 9. Now, yeah, this right here might be like just like one of the equations that you will do like in the early days, but people still kind of make mistakes because we have fractions. So what's the best way to do this? 1/2, 3/4, 7/8. Multiply everybody by the lowest common denominator. So let me just make a note that lowest common denominator 2, 4, 8. 8. So I'm going to do this. Multiply this by 8, multiply this by 8, multiply the 6 by 8, multiply this by 8. So I'm going to write them down, like right next to it to make it clear. So that 8 times 1/2 is just 4x. This and that reduce. 2 times 3 is 6. And then 8 times 6 is 48. And then 8 and 8 cancel, so that's just plus 7x minus 9. Much better this way. Now distribute the 6. And then distribute the 7. Oops, that should be a 9. So 7x minus 63. Okay, combine that term. So that's 10x plus 30. And then that's 7x minus 15. And then 10x minus 7x is 3x. Negative 15 minus 30 is negative 45. Divide 3 to both sides. X is equal to a nice number 15. Another cosine sine equation, but we're almost done. So seriously, if you're taking pre-calculus, hopefully you get to know all these equations, and this video can really help you master all the equations that you have been encountering or you will be encountering. All right, and then remember, I'm doing this with you guys, right? So, next one. 2 cosine square x equals 1 minus sine x. Cosine square and sine x, we want everything in terms of just one trig functions, right? Let's use the Pythagorean identity to simplify that. So I'm going to write this as 1 minus sine square x. Distribute the 2. Okay, and then I'm going to move this term to the right hand side, and then I'm also going to move the 2 to the other side. So I'm going to do this. Okay, 有点累。Okay, that was enough rest. Okay, I'm going to move this to the other side, so I will get positive 2 sine square x, yeah? And then minus sine x, and then 1 minus the 2, so it's minus 1, so that's all equal to 0. Just kind of move around. Now we can actually factor it. We can do the tic-tac-toe real quick, sure. So it's 2 sine x and sine x. We need a negative sign, so negative 1 here and 1 here. This times this is negative 2 sine x. This times this is sine x. So together we do end up with our negative sine x. So that means 2 sine x plus 1 times sine x minus 1 is equal to 0. From here, sine x has to be negative 1/2, and from here, sine x has to be positive 1. Now, we have done a lot of this already, so this one definitely go ahead and give it a try. We get 2 expressions for the solutions right here. I'm just going to tell you x is equal to, I'm going to write down the answers for you guys. We have pi over 6 plus hold on. Okay, something is wrong. Oh, no wonder. I copied down my question wrong. It's 1 plus sine x. I'll do it again. Okay, number 95, we have 2 cosine square x is equal to 1 plus sine x. So we just want an equation with just one trig function, right? So for the cosine square x, we can use the Pythagorean identity to replace that. So that's 2 times 1 minus sine square x. And that's 1 plus sine x right here. Distribute the 2, so 2, and then minus 2 sine square x is equal to 1 plus sine x. Now, I'm going to move this to the other side, so it becomes positive 2 sine square x. And then this is still positive sine x. Now we have 1 minus 2, so that's minus 1. Okay, and then for this, we can factor it by the tic-tac-toe. Have a look. 2 sine x times sine x, and then to get positive sign, we want 1 and negative 1. So this and that is 2 sine x. This and that is negative sine x. So the factoring is 2 sine x minus 1 times sine x plus 1. Now, from here, sine x is equal to 1 over 2. From here, sine x has to be negative 1. Now, we have done a lot of this already, so for this one, definitely give it a try. I will tell you though, for this right here, x, you will have 2 expressions. The first one is you start it at pi over 6, and then you add 2n pi, and then you can also start at 5 pi over 6 and then you add 2n pi. Okay? So these two are from here. Now the last one is for sine of x is equal to -1. You start at 3 pi over 2 and then you add 2n pi. So 3 expressions right here for you guys. 96. Rational inequality again. So I'm going to erase this. X plus 4 over x plus 3 less than x minus 1, x minus 2. So x minus 2, x minus 1. So 1, 2, 3, 4. You can see that. Now, do not cross multiply. None of that. Move this to the other side. So it will be a minus. And then that's still less than 0. And get the common denominator. I need x minus 1 here and also here. And then here we need the x plus 3. Okay. Now they have the same denominator. So x plus 3, x minus 1. Right here I'm just going to expand it. So here we get x squared. And then that's minus x plus 4x, which is plus 3x. And then minus 4. Here's a minus. Be careful though. Minus, I'll put parentheses because later on we'll have to distribute. X times x is x squared. X times that is 3x. Minus 2x is plus x. And then minus 6. So if you distribute it, you get x squared plus 3x minus 4 minus x squared minus x and then plus 6 all over the denominator. Okay, good thing this and that cancel. This and that is 2x. This and that is plus 2 over x plus 3, x minus 1 less than 0. And then right here you can factor out 2 on the top real quick. So perhaps I will do that right here. I will just do that right here. So 2x plus 1, x plus 3, x minus 1. Okay, what numbers do we care? Okay, care about -1, -3, and 1, including none of them, yeah? So here you go, number line, -3 go first, then -1, and then 1. And then open, open, open. Okay, pick a number. Less than -3, let's say -4. Plug in here, top is negative. Plug in here, that's negative. Plug in, that's negative. All three together is just all negative. So we want it because we're trying to get negative. So we want this. And then they are all to the first power. Skip this, take that, skip that. So x is less than -3 and x is in between of -1 and 1. So negative infinity to -3, -1 to 1. Okay. Alright, number 97. Looks kind of simple. Sine x plus tangent x is equal to 0. but be careful. How do we do it? Write this as sine over cosine first. So sine x plus sine x over cosine x. Can we multiply everybody by cosine x? Well, in this case, yes. You never want to divide like a cosine x to both sides because otherwise you might be dividing by 0. Then how come we can multiply everybody by cosine x? We're multiplying both sides by 0. Well, actually, when we're solving a rational equation, we can just multiply everybody by the denominator. So that's okay. Just to make sure don't divide. This times this is, let me write down the sine x first. This times this cosine x cancel, so, and then cosine x times 0 is just 0, so it doesn't matter. Now we can factor out a sine x. Plus 1 is equal to 0. So now, from here, we see sine x is equal to 0. From here, we see cosine x is equal to -1. For sine x equal to 0. Alright, let's do this real quick. Let's do this y value on the unit circle. Here or here. So the x is just n pi. Right? Starting from here, just add pi, subtract pi, and all that stuff. Now, for cosine x equal to -1, check this out. Cosine is the x value. It's right here. It's -1. And this is -1 comma 0. Then -1 comma 0. -1. So in fact, we have that already. The answer is just n pi. Then pretty nice. Okay, number 98. And we also have to make sure that cosine x is not equal to 0, but it's not. So we also have to make sure that cosine x is not equal to 0, but oh good, we are not saying like pi over 2 or 3 pi over 2, so we are all good. Okay, now number 98. We have log equations with two different bases. Log base 9 of x plus log base 3 of x is equal to 1. Now be really careful because when we have different bases, we cannot just combine it right away. So what do? We can use the change of base formula, and I'm going to write that down right here for you guys. Whenever we have log base b of x or something, we can change the base. We can say this as, take a common base, let's say the natural one, ln x over ln b. That's okay. Or we can also use the log base 10, right, log of x over log of b. Either way, it's okay, right? Let's use ln because it's cooler. Doesn't matter though. So I'm going to change this to ln x over ln 9. And then right here, I'm going to change this to ln x over ln 3. And that's equal to 1. Now what? Well, the 9 is the same as 3 squared. I'm just going to write it like this. And then we can put a 2 to the front. So this is the same as saying ln x over 2 ln 3 plus ln x over ln 3 is equal to 1. Now, if you would like to multiply everybody by 2 ln 3, sure thing. It's really up to you. I think I will just do that. Why not? Multiply everybody by 2 ln 3. This times this is just ln x plus this times that. ln 3 cancel. We have 2 ln x. Then this times 1, we have 2 ln 3. Okay. Now, we have the 2. I want to combine them. I'm going to put this up here. So this is ln x plus ln of x squared. And then remember, whenever we have log of x, we are saying x has to be positive. Yeah? So keep that in mind. And I'm also going to do this. I'm also going to put the 2 back here. So that's ln 3 squared, which is 9. I'm going to do that later. Oh, I could also have combined this to be as 3 ln x. Doesn't matter. This right here is just ln of x plus, it's the same as multiplying by the second one. So that's ln x cubed. It's equal to ln 9. Now here's the deal. If two ln's are equal, that means the inside must be equal. So x cubed must be equal to 9. Okay? Then we can just take the cube root to both sides. And remember, I'm not going to find the complex solutions for this because originally it was a log equation and we are not solving for non-real solutions for log equations. So here I will just take the cube root and then x is just the cube root of 9. The answer is not 3 though, it's just cube root of 9. We can't really simplify that. Number 99. Exponential equation, but more fun. E to the x minus e to the negative x over 2 is equal to 1. If you notice what this function is, you can leave a comment down below and let me know. Something with the h. But right here, I'm just going to solve it the normal way. Have a look. First, multiply the 2 to both sides. So we have e to the x minus e to the negative x is equal to 2. But you know, this right here is really 1 over e to the x. So we secretly have a rational expression here, right? So let's multiply everybody by that denominator again. This times this will give us e to the 2x. I'm going to write it down like this, right? E to the 2x. This times this is just minus 1. And then 2e to the x. Now, I'm going to move this to the other side. Check this out. This is e to the 2x minus 2e to the x, and then minus 1 is equal to 0. This is actually a quadratic equation, but in terms of e to the x. But unfortunately, this time, it's not factorable. So, let me just make it more clear for you guys. This is e to the x squared minus 2 e to the x to the first power minus 1 is equal to 0. So what do we do though? Well, we can use the quadratic formula, but you just have to make sure your answer for now is e to the x. So I'm going to write it down right here. This is e to the x because the input is e to the x. And then we will have, okay, I'm going to do this. Negative b is negative 2 plus or minus square root of b squared, which is negative 2 squared minus 4. A is 1 and c is negative 1 all over 2 times 1. Okay? Now, take this all the way here. The left hand side is still e to the x. On the right hand side, we'll simplify this. That's 2 plus or minus, take the square root. That's 4, and then 4 plus 4, so it's 8. So 8, and then over 2. And moreover, square root of 8. Break it down, this is square root of 4 times square root of 2. So this is e to the x equals 2 plus or minus 2 square root of 2. You can do it like over 2 here and over 2 here. So e to the x equals 1 plus or minus, cancel just square root of 2. Now, be careful. It looks like we have 2 answers, but no, we only have 1. Because square root of 2 is bigger than 1. So note, 1 minus square root of 2 is negative. And then whenever we have e to the x, this right here is always positive. So the negative answer here is not going to work, so we'll just get rid of that. So e to the x is equal to 1 plus square root of 2 only. Then take the natural log to both sides. Cancel, cancel. X is equal to ln of 1 plus square root of 2. And that's the only answer for that. Alright, this right here real quick. This equation is the same as asking what sinh of x is equal to 1. And that's the hyperbolic sine function. And you can say this. X is just equal to the inverse hyperbolic of 1. This is really the same as that. Right, so it depends if you have done this in your pre-calculus class or not, but usually, most likely you are going to see that in Cal 2. Alright, cube root of 4x squared minus 4x, this is equal to x. No worries, no worries, seriously. Just get rid of the cube root by cubing both sides. Not bad at all. This is 4x squared minus 4x equals x cubed. Now, we usually want to leave the leading term with positive coefficients, so we'll move these two terms to the other side. Write it down first though, so it will be minus 4x squared plus 4x is equal to 0. Then factor out the x, and then this is x squared minus 4x and then plus 4, that's equal to 0. Factor this, we get x minus 2 squared is equal to 0. So as you can see from here, x is equal to 0 or x is equal to 2. Technically, x equal to 2 happening twice. So this right here is our answer, and that's question number 100. And as you know it, how can I not have question number 20? How can I not have question number 101, right? This one is going to take a long space because I want to give you guys a fraction equation with 4 fractions. Just ignore the scratch work that I did. Alright, 101. 3 over 2x minus 4 plus 1 over x squared plus 3x plus 2, and then that's equal to 1 over 2x minus 4, and then minus 2 over x squared minus 4. So the first thing is that we are going to just factor the denominators. So I'm going to just write it down again. So this is 3 over 2 and then x minus 2. Plus this is 1 over x plus 1, x plus 2. Okay? And that's 1 over 2, x minus 2. And then finally, 2 over x minus 2, x plus 2. So it's a big one. Now, we are going to multiply by what though? Number-wise, we need a little 2. Okay? Do I have enough space? Let me rewrite it again, sorry. So I'm going to factor out all the denominators. So this is question number 121. Have a look. I'm going to factor out all the denominators. So 2x minus 2 plus this is 1 over x plus 1, x plus 2. And then that's 1 over 2x minus 2. Okay, you know what? There's a slightly easier way, just notice. Because they have the same denominator. Okay, this is question number 101. So notice, this and that, they have the same denominator. So I can really just minus 1 over 2x minus 4 to both sides. So this and that cancel. And then we're just looking at 3 minus 1, which is 2, over, and then this right here we can factor the denominator, like that. And then continue, plus 1 over, factor that, x plus 1, x plus 2. And then this is 2 over x minus 2, x plus 2. And guess what? This 2 doesn't even matter, it's just 1. Now, this is slightly better. I'm going to multiply everybody by, let's see the denominator. We need the x minus 2. Right, get rid of that. That will get rid of that. We also need the x plus 1 from here. And then lastly, we also need the x plus 2. Okay. Now, when we take this, multiply with that, the x minus 2 cancel. So we just have, I'm going to write it down, x plus 1, x plus 2. Okay. Next, we add 1. This and this will cancel, so we just have x minus 2. Lastly, 2. This cancel that, this cancel that. We have the x plus 1. Okay, so it's just a quadratic actually. Expanded, this right here is x squared. 2x plus x is plus 3x and then plus 2. And then that's just plus x minus 2. That's 2x plus 2. Okay, so that's x squared plus 4x. And this and that cancel. Okay, I'm actually just going to minus 2x to both sides. So this is x squared plus 2x, and then that's equal to 2. Because I see that if I put a 2 to the other side, it's not factorable. So right here, right now, we are going to complete the square. Take half of it, it's just 1. Square that is 1. So just add 1 to it, add 1 to it. So ladies and gentlemen, the left hand side gives us x plus 1 squared. The right hand side is equal to 3. And the right hand side is equal to 3. Hold on. I think something's wrong with this. Because, let me just double check. It's tiring, so just give me 1 sec. Because my answer key is different than the thing I'm about to get. Okay. Yes. I'm going to do this again. Ladies and gentlemen, question 101. As you know it. Alright, so 3 over 2x minus 4, and then plus 1 over x squared plus 3x plus 2 equals 1 over 2x minus 4, and then minus 2 over x squared minus 4. 4 fractions, but we can actually knock out one of them because this and that, they have the same denominator. We can just minus 1 over 2x minus 4 to both sides. So this and that cancel. Have a look. 3 minus 1 is 2, and then we have the same denominator. And in fact, we can factor that out. Factor out the 2, and then x minus 2. And I'm also going to factor out the rest of the denominators. So this is x plus 1, x plus 2. And then this is equal to minus 2 over x minus 2, x plus 2. And then, you see, this and that reduces to 1. Very nice. So now, I'll just multiply everybody by the lowest common denominator, which I need the x minus 2. I need the x plus 1. And I also need the x plus 2. It looks like we have like a cubic, but no, don't worry, because when we take this times that, the x minus 2 cancel, and the top is just 1, so we just need this. So first we need x plus 1, x plus 2. And then we add these cancel, we just have this times 1, which is x minus 2. And then this is minus 2. These and that cancel, so we have the x plus 1. Now, let's expand this. X squared plus 2x plus x, which is 3x, and then plus 2, plus x minus 2 equals, that's negative 2x minus 2. Combine like terms, oh, this and that cancel, but 3 and 1 is 4. And that's equal to negative 2x minus 2. Now check this out. I'm actually just going to add the 2x to both sides. Because if you move the negative 2 to the other side, it's not factorable. So I'm just going to look at this. X squared plus 6x, and then leave a space. And that's equal to negative 2. Now, we're going to complete the square. How do we do it though? Here's the geometry. Here's a small bonus. Here's the geometry. Have a look. X, it's like this. It's like a segment with x. And then x squared, you can just make it into a square. So this portion is x squared. But now what's 6x though? Well, if I draw 6 right here, I'm not going to have a chance to get a square later on. So I'm going to cut this into 2 parts, 3 and 3. Let's say this right here is 3. And I'm also going to put 3 right here. Have a look. If I finish this, this right here will be 3x. This right here will be 3x. Right? As you can see, aren't we, like, we're just missing a little square. We can almost complete the square, right? So how are we going to finish that? Well, the answer for that is, we just have to ask ourselves, what are we missing? 3 times 3, which is 9. So I will just come here, and then we just have to add 9 to it, and then add 9 to it, and that is exactly how we complete the square. Ladies and gentlemen, x plus 3 for the left hand side. So this gives us x plus 3 square, literally a square, and that's equal to 7. Now, take the square root to both sides, plus minus, cancel this guys. X is equal to, put a 3 to the other side, that's negative 3, and then you have the plus or minus square root of 7. Let me see the bad numbers. From here, x cannot be 2. From here, x cannot be negative 1, cannot be negative 2, cannot be negative 2, cannot be 2. Well, x is negative 3 plus or square root of 7. This right here has nothing to do with them. So both of them are the answers. Done. Done. Let me see. Alright, 5 hours and 23 minutes. Not so bad. Not so bad. This is how my hand looks like. And then this is, yeah, what I'm using. Okay, so if you guys have seen my 100 videos before, then you know at the end I would like to show you guys a marathon medal that I have earned before, because this is like doing the marathon. I could have run a marathon earlier in like 5 hours. This is the one from 2017. It's the San Francisco Marathon. The San Francisco Marathon. In my opinion, one of the prettiest marathon medal I ever have. And I'm going to put this here. I'm not going to touch my medal with my right hand. Well, I still did. Anyway, so hopefully all this right here can help you, right? I know algebra, you just have to get your hands dirty, like literally practice a lot of them. If you are serious about learning math, going to like science, math, yeah, algebra should almost be your second nature. Should be able to do it fast so that you can actually focus on learning the calculus, the physics, the other stuff. Later on, if you are learning calculus and physics and if you are still worried about the algebra, it's nearly impossible. So hopefully this video can benefit you. Let me know how it goes. And as you know, that's it.